Hey guys, this is Martin, and today we are going to look at a SQL injection lab from the Portswigger Academy. So the title is SQL Injection Vulnerability in the Where clause, allowing retrieval of hidden data. Okay, so let's load the page first, and then we can see here we have products, right? So we have a total of 12 products visible at this point in time. And then you can also refine your search. Like, for example, you can just look at pet products, and then you will see that there is a filter parameter up here, and then a category says pets. So the first thing you want to do is basically you want to find out whether any parameter is vulnerable to SQL injection. So by doing this, you can, for example, put a tick value at the end of it, and then you hit enter, and we get an internal server error. So an internal server error is always a sign or a hint that there might be a SQL injection, whether that's blind or whether that's like a standard SQL injection. That's dependent, but basically that's how you test it. And then you can see this request here. It says percentage 27, which is basically the URL encoded equivalent of a tick. So I sent this over to repeater so I can play with it. And if I remove this again, so I can just retrieve my pets category, right? Like, and then I can render this. Doesn't really give me nice information at that point, but it doesn't really matter at this point. So what I want to do now is I'm trying to see products which basically which are not listed at the moment. So if we go back to the lab description, it says here, lab contains a SQL injection vulnerability in the product category filter, right? So as we suspected with our little test, and there is basically an SQL query being done, select star from products, where category equals gifts and released equals 1. So this is like server-side code, and basically you control this part here. You control the parameter. And so the vulnerability really arises because it's not sanitized. So it accepts user input. It doesn't use so-called parameterized queries or prepared statements or something, which are protection mechanisms against SQL injections. So basically what I'm going to try now is I want to get rid of this end released equals 1, right? Like, so I don't want this to be evaluated at all, right? So I want to see all the products, not just the ones which are currently released, which the administrator set to released. And doing that is, for example, I can enter here my SQL injection tick again, and then I can say, for example, or 1, I always have to work with the plus signs, 1 equals 1, and then I terminate the query. So basically what this is going to do here is it will, by using this tick, you will basically terminate this parameter with a tick, which normally in the real world scenario, in a secure scenario, it should not allow this. And then I'm introducing a logical condition which says, or 1 equals 1. And 1 equals 1 is always evaluating to true. So in other words, what that means is it's basically saying pets category or 1 equals 1. So anything basically. And what I'm doing here is I'm terminating, so these 2 dashes is the termination string for to terminate a SQL query, right? So what's going to happen here is basically this end released equals 1 is not even evaluated anymore because I terminated the query before that, right? So let me give this a try. Let me put this in and see what happens. And I get a 200, okay. And basically, if I go back to my lab here, I will see I have solved the lab, right? So I have solved the lab. So let's redo this real quickly. Go back here to the home page effectively, and then let's do this in the browser. So you remember we had the pets category, so we used that, and then we simply put it in here. So I will put in tick, and then or 1 equals 1, and then terminate the query. And I do this, and now I can see I have many more products in here. Remember, initially we did the same test and it was like 12 in total. And now we have 2, 4, 2, 8, 12, 16, 20. So we made the additional hidden ones, which were 8 products in total, we might make them visible as well by simply doing a simple SQL injection. Okay, that's it for today's video. Thank you very much. Hey guys, this is Martin again. Today we are looking at another SQL injection vulnerability. This time the lab is SQL injection vulnerability allowing login bypass. Okay, so effectively there will be a login functionality in the web application which is vulnerable to SQL injection. And let's get started. So first and foremost, for a better understanding, effectively, the login process makes a query to the database, which looks something like this. Okay, so it selects star from users. So where the username equals the username and the password equals the password. If this end condition and logical condition evaluates to true, the login functionality will proceed, right? If the password is wrong, then it will disallow you access. So there is a bypass to this. Once again, the problem here is that there is no parameterized queries and there is no prepared statements for SQL injections. So an attacker can abuse this functionality, and I will show you how this works basically. So let's head over to my account this time around, and this is our username and password field. So I'm entering administrator because I presume there's an administrator and a password of test, right? And then I do a login and it says invalid username or password. Let's head over to Burp. Let's check this in our history. That's our post request here. Okay, so you can see if I send this to repeater, I can repeat this. There's a CSRF token as well, which protects against cross-site request forgery, but that's topic for another video in the future. Username administrator and password equals test. Okay, so this is basically what is being sent over. Now I can start fiddling around with the request. So what happens if I say administrator and then I put the tick and I put the dash dash? So what I'm doing effectively here is, if we go back to our query statement, is I'm putting in administrator and then I'm basically putting the tick. So what the tick means is I'm breaking out of this username parameter here, right? So this is what I'm effectively doing, and then I'm immediately ending the SQL query with the 2 double dashes, and that means that for the application, logically it now means when the username is administrator, log me in, right? Because I have interfered with the syntax here. So the end password is not even evaluated anymore, right? Because with my 2 double dashes, I'm effectively terminating the query. So this second condition is not even evaluated. So let's see if this works. So we do administrator tick dash dash and then password test. So I could put anything in and then I hit login. And then I'm logged into my account. You see this? So I was effectively able to bypass the login mechanism by simply terminating the query, breaking out of the username parameter, and then terminating the query so the password is not even evaluated. Okay, so this is a very simple form of SQL injection for authentication bypass. Thank you. Hey guys, this is Martin, and today we are taking a look at a cross-site scripting vulnerability. In this case, it's a reflected cross-site scripting vulnerability into the HTML context with nothing encoded. So this is a very simple reflected cross-site scripting vulnerability in the search functionality of the application. And our job is really like just to call the alert pop-up window. Okay, let's get started. Let's head over to our page to our vulnerable application. So you can see this is a blog and there's a search option. What I like to do first is like to just search for a name and see what's actually happening. So I can immediately see that there's a search parameter and then my input is being put into that search parameter, right? And let's head over to Burp and take a look at this more closely. So let's send this to repeater so we can play with it. It's our search, and then you can see Martin is my search term. So what happens if I look for Martin in the response? I see that it's being it's reflected, right? It's reflected over here in an H1 tag effectively, right? So if I look a bit further, I can see this is within the HTML tag, so this is why it means it's reflected in HTML. Okay, so what I can try now is I leave Martin in there because then I can easily search for Martin, but I can start putting in like a script tag for JavaScript, say alert, or let's just send the script tag as it is. So just do script and then look for Martin, and you see that my script tag is being reflected as is. So this means, in other words, there is no filtering taking place, there is no encoding taking place. So they're not preventing against cross-site scripting attacks because my script tag was taken into HTML code and will be seen by the browser once it's being executed as actual JavaScript code. So it's not interpreted as text, it's basically seen as code, and that's the vulnerability. So let's complete this here, put an alert in there, an alert 0, for example, simply for a small pop-up window, and then to close the script tag, send this. Let's look for Martin again here, and you can see here is our payload effectively, and this will be working fine. So how I can test this is I can go here in Burp on the GET request and say show response in browser. I copy this, and then it's already solved the lab because it already took it. But just to show you the pop-up window, here you go. So this is the pop-up window. Another way of doing this is obviously you could go in here, and as you see this, you can put it into the URL directly, which is the same thing effectively. Sometimes you have to work with URL encoding a bit and stuff like that, but this is the same what I've done in Burp repeater basically. So if I do it once again, you can see here's the pop-up window. This is the cross-site scripting vulnerability. Okay, I hope you found this useful, and I look forward to see you in one of the next videos. Hey guys, this is Martin. Today we are taking a look at another lab from the Portswigger Academy. This time it's a stored cross-site scripting vulnerability into HTML context with nothing encoded. So quickly, the difference between stored and reflected. Reflected simply means that you need to manipulate a parameter and then the XSS is being executed on the fly, so to speak. In order for a victim or in order to exploit this practically, you would then need to send a link to the victim, and then the payload is being executed. So this is slightly less dangerous than a stored one. A stored one is more dangerous because the stored one is being retrieved from the local database, and in order to execute it, it's merely enough that the victim browses to that page which retrieves the stored XSS payload. Okay, let's take a look at the lab. So first and foremost, you will notice there is no search bar in this lab, but this is a blog. So let's go here and let's go to our blog. And you can see here you have the options to comment stuff in there. So what happens is in a real world scenario, you would test all these parameters, right? Like you would test the comment field. This is user controllable, name, email, and website. We already know that the vulnerability here is in the comment field. So what happens if I just put a script tag in, a simple script tag, not the full payload yet, say test, and then post a comment, and then go back to the blog, and you can see that there was a test, but I don't see the script tag. But that may not mean anything because the script tag may be reflected in HTML. So this is why we go there. So first of all, we send the request to repeater to play with it. So that's the post request. That was the one where I actually posted it, then we got the confirmation, and then we loaded the actual post once again. So let's send this to repeater as well. So now we have like these two in here. So here you can see this was my comment, and the comment here is wrapped. Well, the angle brackets are basically percentage 03 for the open angle bracket, and for the closing angle bracket is percentage 3A. Percentage 3C is the URL encoded equivalent of the angle bracket open, and then percentage 3E is the equivalent of the angle bracket closed. So just for your information. So if I send this and I see the 302 found, so basically this is the redirect which we've seen on the web earlier. But if we retrieve it here, right, and we look for a script, for example, then we have a lot of script text because we are loading also other JavaScript resources. But let's see if we find the one which I wanted, and this is basically here. So you see this is being reflected into the HTML. So what I can do now is I can go back here and I basically go to the same blog post, right? View the post, and which is here, and I probably messed up the page now because I put a single script tag in there. So let's choose another blog post. Okay, so these kind of things happen in cross-site scripting. So let's use this one, which is the post ID number 10. Let's put our script in there, alert 0. So this is my JavaScript. And then we just pre-fill this with any stuff, right? Like, and hit post comment. Okay, that has been submitted. And if I now go back to the blog, what happens is the XSS payload fires, right? So, and just to quickly look at this in the repeater again. So we had our post, right? This was the post we made. You can see this here. This is our script tag. It's basically, if you do a mouse over, you see this in Burp. I said it's URL encoded. Certain characters are URL encoded. So you see this, we selected this text, and here's actually our payload URL decoded, right? Like this is nice to see. And then if we go back to the actual post where the payload fired, if we look for alert, and then you see this right away. Here is our payload, and this payload was reflected within the HTML context. So it's not being put into a JavaScript statement or something like this. We will come back to this later. So this was plain HTML. Okay, I hope this makes sense, and I see you in one of the next videos. Thank you. Hey guys, this is Martin again, and today we are going to look at a DOM cross-site scripting vulnerability in something called the document write sync, and using the source location.search. So basically, DOM XSS vulnerabilities are a special kind of XSS vulnerabilities because they're happening in the DOM, in the document object model, which means it's all taking place locally, right? Like there's no server interaction. It's not being sent up to the server and then reflected down. This is all taking place locally. So you have your search bar. You don't know this normally in an engagement, whether it's DOM or whether it's not and stuff. So what you would try is, like we've done before, you simply take a look, you run the search function, and then you basically take a look at the response, right? Like, and this is the same we done in one of the earlier videos. And then you would look for Martin, and you see it's in an H1 tag. So you would first of all try here your normal cross-site scripting vulnerabilities. You would see it doesn't work in this scenario, but this doesn't mean it's not vulnerable. So this is why you need to take a look at the DOM as well. How you access the DOM basically is you go over to a Firefox browser or Chrome browser, and then you simply say inspect this element, right? And so this is opening the DOM. So it's always important when you look for cross-site scripting vulnerabilities that you look at both the source code as well as the DOM, because the reason for that is certain things you don't see in the source code. So for example, if there's like an AJAX call being made or something like this, this will be appended to the DOM, but you won't see this in the source code. So it's always important to check both parts of it, right? And then here you have a search functionality, so you can search for Martin, because that was my search term basically, and you see there's two results. So the first one is the one we have already seen, right? Which is in the H1 tag. And then the second one is basically in the DOM here, right? So it's basically in an image source attribute, and then you see it's being reflected here. Now, my thinking here is first of all, I need to break out of this image source tag, right? Like I need to break out of this in order to inject my payload. So how can I do this? I open simply text editor here, and then I would say here, I need to put the double quotes and then close the tag basically. And then I can say like SVG onload, which is a very basic JavaScript instruction within the SVG tag, and then I say alert 0, and I close this out, right? So let's try this. Let me use this, and then now basically I put this into my search bar once again. I hit search, and here I get my cross-site scripting vulnerability. So this was basically, I can then go back here and look for alert in my DOM, and then I see here that it has broken out. And the important part to notice is not this one. This is still in the H1 tag. So this is the header tag. This is not important. But what happened down here is was successfully able to break out of the image tag, as you can see this here, right? And then in the new line, sorry, now I moved it over here. In the new line down there is the SVG onload alert 0. And that's basically triggered my DOM XSS cross-site scripting vulnerability. And when you talk about DOMs, you always talk about two things. Number one is the source, which has to be user controllable. The source in our case was the search function, right? Like as it explains here, this is basically the document, the location search, that is the source, and the sync is the document write. This is basically a function which writes it out to the page. And this is a dangerous sync, because if the user input is not sanitized, you can introduce cross-site scripting or other code vulnerabilities, which we have just done. I hope this makes sense, and I look forward to see you in one of the next videos. Hey guys, this is Martin again, and today we have another lab called DOM XSS in inner HTML sync using the source location.search. Okay, so basically this lab contains a DOM cross-site scripting vulnerability similar to the one we have seen before in the blog post functionality. It basically uses the inner HTML assignment, which changes the HTML contents of the div element, okay, using the data location search. So once again, we have like two issues here. First of all, the location search is user controllable, and then there is no sanitization, and it's being passed to an insecure sync, which is the inner HTML sync. And we were going to take a look on how to exploit this basically. So first and foremost, you go in here and then you would simply put in like a search or something. You search for Martin. You could then go over to Burp, which we have done in the previous videos, but it's not reflected, or there's no cross-site scripting vulnerability server side. So this is a DOM vulnerability. And that means everything is happening locally with client-side JavaScript. Okay, so let's open up DOM Inspector again. Okay, so let's take a look at the DOM here, and then we basically see there's this span ID element. Okay, so this is the first clue that something is going on here. And down here you see a script, and in the script you actually see that it takes that user-controlled input, the search message, and then it's putting this into inner HTML. So it's transforming this effectively, and it will be rendered as HTML in the DOM. Okay, so with that in mind, what happens if I put like an image tag or something, an HTML code in there, like for example, img source, like something like this, right? So img, so I'm loading an image from the source X. The source X doesn't exist, right? So that means it will give me an error undoubtedly. So then on error, because I produce an error, and then when the error is being encountered, it will fire the alert 0. So let's try this. And here we go. So you see that our cross-site scripting payload was successfully executed in the DOM. So to take a look at this, you could then come over here and take a look at the DOM effectively. So we go here and inspect this element, and we see that our element, like from the span ID, the search message, which I showed you earlier, I simply included this here. So there was no sanitization, there was no filtering in place. It was straight passed on to the inner HTML, and this is what caused our payload to execute. Okay, I hope this makes sense, and I look forward to see you in one of the next videos. Hey guys, this is Martin again. Today we are taking a look at another DOM XSS vulnerability, this time in jQuery in the anchor href attribute sync using the location search source. Okay, so let's get started here. If we head over to the lab description, so there's a DOM-based cross-site scripting vulnerability in the submit feedback page, okay? And it uses the jQuery library $selector function, which is quite common, like to find an anchor element and then changes its href attribute using that data. So sounds cryptic, but basically this is a redirect parameter effectively, which then, so jQuery is being used to control this, and I'm going to show you like how this is looking like. So this is the submit feedback page. If we head over to the submit feedback page, something which immediately stands out here in the URL is that there's a return path, right? So wondering what this return path will do. If you change this return path to Martin, for example, hit enter, and then what's happening, jQuery is doing its magic in the background, and it's effectively putting that that redirect, which I just put in there, into my URL on the back button, as you can see this here. So it now says websecurityacademy.net/Martin. So you can analyze certain parts of this as well here in Burp. So this is basically the return path, which is the redirect parameter, and then this is what I actually specified, right? However, you will find that a lot of things you cannot really find. So if you search for Martin, I don't see this reflected here in the response. Now, reason for that, because it's happening in the DOM. So as we had in one of the previous videos, you may or may not see all the output. But what immediately stands out here is basically this script function, which basically takes like the backlink. This is basically like this parameter, and then it puts it into the href tag, and it takes it from Windows location search, which is like the URL, and then it takes it from the value return path, right, which is this one here over here. Okay, so I already seen that I can control this. And so what I'm going to do next basically is I will change this. Instead of Martin, /Martin, I would put in JavaScript. And then I would say alert 0. Okay, and I hit enter. And that already solved my lab. But you haven't seen the pop-up yet, but what would happen is if I click the back button, you see here on the left-hand corner that the JavaScript alert 0 payload has been successfully put into the href tag. And if I click this, I fire my cross-site scripting vulnerability. Okay, I hope this makes all sense, and I see you in one of the next videos. Hey guys, this is Martin, and today I'm showing you another DOM cross-site scripting vulnerability, this time in the jQuery selector sync using a hash change event. Okay, so the lab contains a DOM cross-site scripting vulnerability. Again, DOM cross-site scripting means it's taking place locally with local JavaScript, so there's no server involvement. And the vulnerability is on the homepage. It uses the jQuery $selector function to auto scroll to a given post whose title is passed via the location hash property. Okay, so sounds complicated again, but it's actually not. So in reality, what that means is we go to the homepage first, we load it, and then we have already been told that the vulnerability is on that page. So we are going to take a look at the source code and see if we find anything interesting. And down here, actually, you will find the vulnerable script, the vulnerable functionality. So it's basically when there's a hash change event. So this is the first information is there's obviously I can operate with the hash sign. So when there's a hash change event, a function is being called, which pretty much takes the input, right, and will then scroll into that specific functionality. So to show you this in an example, how this will work, like here, you're on the main website, right? And then you have, like, so for example, faking it or interviews. Let's take interviews and then let's see how this works, right? So we are on the main page, and then I would introduce like a hash sign and then put in interviews and hit enter. And then you see it scrolls me directly to the interviews. So what I'm thinking immediately from a hacker's perspective, if I can control this input, I may be able to insert a malicious payload, like a malicious cross-site scripting payload. And instead of scrolling to a certain function, I may be able to invoke a command. So here I have a basic command, right? Image source XXX. So a non-existent image source. And then when this is loaded and there's an error, then invoke the print function, right? Like we did the alert function, the pop-up box earlier. Now let's use the print function and see what comes out of it. So if I do this, I put it in here and I get the print function, right? So this means the code is vulnerable. I have confirmed everything. But now how do I make use of it? So the problem is, remember, it's a hash change event. So if I reload this again, it will not fire, right? The reason why it will not fire, because there's no hash change event, because it's the same payload. So what I can do, for example, is I could now make a change to this and say like image source XX, and then it would fire again, because now there was a hash change event, because the value after the hash was changed. Okay, so how to exploit this, or how to get this actually to the victim, because it's a DOM cross-site scripting vulnerability which takes locally place. We have something here in Burp called the exploit server. So on the exploit server, I can craft a payload, and then that payload can be sent to the victim, and if the victim then opens it, basically this is being fired. Okay, so in order to put a payload into the exploit server, you can create something like this, and we will go through this step by step. So this is simply like an iframe, which means it's loading an iframe. The source of the iframe is specified here. So this is our main vulnerable website. And then we have the hash event. And then we tell the script on load. So when this is being loaded, basically insert this payload after the hashtag, right? So this is the payload we just tried, and we've seen that this worked, but this is now like how to scale it out and how to actually get it to the victim. So if I store it, I can test it myself by clicking view exploit, so see if this works. And I run this, and here we go. So I have my vulnerability, and it's invoking the print function. Fantastic. So I go back, and now I know that my exploit is working. I can deliver it to the victim. So I'm basically sending this like with a fictitious email to the victim. Victim clicks the link, opens this up, and then basically gets exploited, or the DOM cross-site scripting vulnerability gets invoked. So in reality, this wouldn't make sense, because you're simply, the victim who clicks does simply get the print message. But what you would normally do is you put like a payload in there where you exfiltrate a cookie or something like this. But this is not part of this video. Okay, so let's deliver this to the victim, and we're sending this over to the victim, and the lab solves, because the victim obviously has loaded this, and the exploit was then fired in the victim's context. I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin again, and today I'm going to show you a reflected XSS vulnerability into something called an attribute with angle brackets HTML encoded. So our classic payload, which we have done in one of our earlier videos, will not work. I will demonstrate this real quick. So if I do like a script alert 0, like one of the earlier labs, and it will not fire the XSS payload. Why is that? Let's take a look here at our request, which we sent. Resend this, and then search for alert over here. You will see that both in the H1 title tag as well as in the value attribute here, it is basically encoded. So if you see the percentage LT, and if you see like those kind of like percentage GT, which is the closing bracket and stuff like that, that means it's encoded, so they are taking precautions against cross-site scripting attacks. Nonetheless, it's still vulnerable, and I'm going to show you how to exploit this. So basically, if I do this with a normal search, like I say Martin, for example, and then I want to see exactly where it's being reflected, and it's being reflected here, for example, right? Like in the value attribute. So first thing I was thinking is like, hey, can I break out of this value attribute and then add my own, right? Add my own attribute. So I'm trying this. So I simply put like double quotes, and then I could use like an event handler, right? Like for example, there's various out there, like on the Portswigger website, you find all the different event handlers, but let's take a basic one like on mouse over, right? Like, so this means XSS will fire or whatever I instructed to do when I do a mouse over that specific page. So let's put this in, search for on mouse, and then you can see here, I was successfully able to close the value tag, as you can see, right? Like, so you have like the double quotes and then double quotes again. So I was able to break out. And so next step for me would be like I do an equal, right? Like, because I want to put my alert function. So let's take a look at this. And then we basically see, yes, it also took the equal sign. So it wasn't encoded or any of that. So what else do I need to do? I already have in the code a double quote, but I also need another double quote because like the value has to be in two double quotes basically, right? Like, so one is not sufficient for my payload. So I also need to introduce another double quote as shown here. And now you can see this. Now I have the two double quotes. One was system generated, one was introduced by myself. And now I can actually put in my payload like alert 0, something like this, right? So to fire the cross-site scripting. Let's check how this looks like. And if I go down here, I see I have on mouse over now, the attribute, the event handler, and the alert 0 in there. So again, there was no filtering. So the round brackets are not being filtered. That looks good. So let's show this show the response in browser and see how it looks like in the browser. You can see the lab is already solved because the server already detected that I was doing this successfully. But let's just do it like this. And if I do a mouse over, you can see it pops my cross-site scripting alert box. Okay, I hope this makes sense, and I see you in one of the next videos. Thank you. Hey guys, this is Martin again, and today we will be looking at another lab, stored cross-site scripting into Anchor href attribute with double quotes HTML encoded. So the lab we are going to look at has a stored XSS vulnerability in the comment functionality. So there will be a comment functionality, and to solve this lab, submit a comment that calls the alert function. So we want to get our alert box popped up. Okay, let's get started here. Let's access the lab. And again, it's a stored vulnerability. So it's not a reflected one. It's a stored vulnerability, and we will be analyzing that functionality. So first and foremost here, it didn't fire up. Let's relaunch it again. And then we get started right away. Here we go. So this is our application. You see there's no search functionality, nothing like this. And we can actually go in here into view the comment posts and stuff. So we can leave a comment, right? Like, so let's do this. Let's put in test at test.com and the website https test and post a comment. Okay. Once we're done with this, okay, the comment has been posted. Let's go back to the blog. And now we go over to repeater. So first of all, we copy the actual post, which we made, which is this one here, to repeater. And then we also copy the actual post, the GET request to that specific post. Okay, so let's take a look at the GET request, right? So we send here like test at test.com as an email, right? So what if we grab for test? And then we see here our, for example, so there's an href attribute, and we put in test at test, we put in HTTPS www.test.com, right? So this is where this was being entered. So now this field may be vulnerable. So let's go in here, and instead of putting the website in like this, we just put in Martin, right? Like, so we call the website Martin. We see what happens. So we are sending the request. We get the 302 redirect. And then if we refresh this and search for Martin, then you can see, so there was no filtering or any of that nature. So effectively, it took my input, even though it probably expects an HTTP or HTTPS, but it basically did not. It did not filter for this. So what I'm going to try next is, what happens if I put like a JavaScript call in there? Before I do that, let me refresh this here. And then you can actually see, like, these are my test commands. And if you do a mouse over, you see there's the link, https test.com. And then the second one was just plain Martin, which is appended here to the main URL. Okay, so now this is interesting because there may be a cross-site scripting vulnerability. So let me now actually change this here. Instead of Martin, I say JavaScript alert 0, right? And then I send this. And then if I do the GET request, so it's sending 302, let's refresh the page. And then here we look for the keyword alert. And then here you can see, this is interesting. So there was no filtering or no sanitization, and the JavaScript alert 0 has been reflected in the href attribute effectively, right? So let's refresh the page here. And then we click on that, and you see in the left-hand corner that the JavaScript alert 0 is visible. And if I click on this, my cross-site scripting vulnerability fires. Okay, so this was another example of a stored cross-site scripting vulnerability, this time in the href attribute tag. I hope this makes sense, and I see you in one of the next videos. Hi all, this is Martin again, and in today's lab, we are going to take a look at a reflected cross-site scripting vulnerability, this time into a JavaScript string with angle brackets HTML encoded. So lab contains a reflected cross-site scripting vulnerability in the search query functionality, and the angle brackets are encoded. You notice here, in reality, you would still check for it, obviously. And the reflection occurs inside a JavaScript string. And I will show you this, how to exploit this. So basically here we have our functionality. First things first, I will look for my own name. I will query this and take a look at the resulting burp request. And I resend this. I search for Martin and see where it's being reflected. So it's in the h1 tag first and foremost. And then also in the variable search terms Martin. Okay, so you can see this here. And what I want to show you real quick is like what happens if I put a normal script alert 0 in. It should be blocked simply for the fact because it says angle brackets are encoded. So you see it's encoded here correctly. That's the encoding in the h1 tag. And let's see down here, and it's also encoded within the JavaScript string. Okay, so this doesn't work. Let's go back to our previous payload and say Martin. Okay, look for that once again. And one thing to notice is, I mean, you're in here, right? Like, you're in here in the variable, in the var, and you already noticed that you're already in a script tag. So I don't really need to define a script tag. What I need to do as a researcher to exploit this is I need to break out of the variable here, right? Like of the var. And basically how I'm trying to do this is simply, let's put a tick and like this, right? Like see what this does do. And then let's see this. And it looks like this worked, but to confirm it, I put like another Martin, right? Like, so I do this, and let me take a look at this. So I have successfully, basically, the first Martin is in the var, And the second Martin down here is basically has broken out of the var. Okay, so I am basically in the script tag itself. So what I would need to do here is simply say alert 0, and then I terminate the remaining script code, right? Like with the 2 forward slashes. Let's see what comes back here. So let's take a look, alert, and this seemed to work, right? So I'm confident that this will fire. So this cross-site scripting will fire. I show the response in browser. I copy that quickly over. It already said you solved the lab because the server has already detected that it was correct, but just to confirm, here you go. So this is effectively it. And once more, like if you want to see this once more fire, you could basically take that payload, this one here, and put it in the search box manually. Okay, you don't have to do that, but this is just to confirm. And then your cross-site scripting fires. Okay, so I hope you found this useful, and I see you in one of the next videos. Hey guys, this is Martin, and today we're looking at a CSRF vulnerability that is cross-site request forgery. So first of all, in a nutshell, what is cross-site request forgery? Is basically you host a script on your attacking server, and then you get a victim to click a link to visit that website, and then that website will basically execute an action on behalf of the victim. So for example, changing an email address and whatnot. But we will take a look at this in more detail and how this works. So this particular one is the simplest cross-site request forgery vulnerability because it has no protections. You will see in future videos there is protection mechanisms, multiple different protection mechanisms like CSRF tokens and things like that. But this one doesn't have any. So it's very straightforward to exploit. What I'm going to do here is I'm spinning up the lab instance. And one thing to note is we've been given credentials. So Wiener Peter is basically our credentials to log in. So CSRF vulnerabilities occur everywhere, but when it comes to bug bounty or to impact, it's really only interesting when it's in an authenticated, locked in functionality, right? Like it's not interesting to launch a CSRF attack against a contact form because you can access this without credentials anyway. But it's more interesting from an account takeover perspective and stuff like that. Like let's log in here. Okay, so I'm logging in as Wiener and Peter, as it said. I log in and I have a functionality where I can change the email address, right? So I go in, I say test@test.com, and then I update the email and I see it's reflected. It's test@test.com. Let's head over to Burp and look at this specific post request which we just sent. So here is that post request to the endpoint my account change email, and it basically was down here is the email test@test.com. So what you immediately see is there's no CSRF protection, there's no token, no unpredictable token or any of that. That means it's relatively straightforward to exploit this. So what I'm going to do is I use an inbuilt tool in Burp Pro, which is called the Generate CSRF POC. And then it's generating you the HTML code right away, which is this here. It also includes like an auto submit that it's completely user interaction free. So all the user needs to do is visit that website or that specific code on the attack server, and then the action is being executed. So I'm copying this out here, right? And I also have the other, like before I do that, I can also test it in the browser, right? So what I can do is let's change test to martin@test.com. Okay, and then let's regenerate this here. And now it says martin@test.com, so that we actually see the impact. And now I can say test in browser, copy this, go over to the browser. Let's open another tab to make this more clear, and then launch it. And then the request is being launched, and you see that now the email has been changed. So if an attacker would have visited that website which hosts that code, their email address would be changed. Now this is a critical vulnerability, obviously, because that leads to account takeover. If an attacker can convince a user to visit a certain page, and all they need to do is visit the page, it changes their email address to the attacker's email address, and then the attacker can basically do a an account takeover by requesting a password reset, right? So we have an exploit server here where we can test this. So let's go back to Burp here. Let's call this hacker in this scenario, right? Like hacker@test.com, send it, and then it should be changed now to, this is not what I wanted to do actually. Excuse me. Basically, what I wanted you to show here is, like, I call it attacker, and then I regenerate the cserf POC, which is this one here. I copy this text. So this is the same thing what I just done with test in browser, but this time I'm hosting it on my own server here, which Portswigger provides. I hit store, okay, and then I send this to the victim, and now the lab is basically being solved. So lab is being solved because all the victim has done, that the victim basically clicked a link, was redirected to that web server, the code got executed within their context of their current browser. So that's assuming they're logged in at the moment, and then the email address was changed to the email address of the attacker. That's the basic cserf vulnerability without defenses. Thank you very much. Hey guys, this is Martin, and today we will be looking at a basic click checking vulnerability with CSRF token protection. So basically, what is click checking? Click checking is a way to masquerade a website. So effectively, you host your own malicious code, and then you embed a legitimate website with an iframe, but it's not visible to the user basically. And then you will give the user a button which says like win a prize, but in reality, when they click on that specific button, it will execute a function on the victim website, like for example, an email change or something like that. But in order to understand this in more detail, we will walk through the lab here together. So first of all, it doesn't really matter if there's a cserf protection token, because the victim is actually executing that action under their own basic privileges, if you wish, right? Like, so the victim will launch the attack. So for that purpose, the victim obviously needs to be logged in to that service, but then the victim has access to the cserf token and then unwillingly uses the post request along with the cserf token. So the cserf token is no protection here in this scenario. Okay, one more important thing here is, yes, we have account credentials, Wiener Peter, and the user will be using Chrome. So in reality, you don't know that, like whether they're using Safari, Firefox, Chrome, whatever. So you need to test it with multiple browsers. But here in this lab scenario, we know it's using Chrome. So I'm using Chromium, which is the built-in browser from Burp, just to make sure that this all works fine. So first of all, I log into my account here just to understand what's happening. So what I immediately see here is basically, this is my account portal, and I have two options: updating an email and deleting the account. So the goal of this exercise is to delete the account of a victim, right? So with that in mind, I have prepared a little skeleton code, which you can find here basically. So this is the skeleton code, and what it does is it's defining an iframe with a certain width, with a certain height, and with an opacity. It's like how visible that iframe will be displayed, right? So when you send it to the victim, you want to change it to a very, very small number so that the victim does not actually see what they're really doing. They shall click on that button, but they shall not see that, hey, delete my account or something like this. But for testing purposes, you leave it at 0.1 usually, stuff like that. And then the second one here, this is basically the button position or the call to action position. So this in the diff here, this is like, it says test me, and this is so you can arrange like in terms of pixels, like the top and the left. And I will show you how this looks like in a real world scenario. And then you host this on your own server, and you embed that banking application or that portal application or whatever you want to click check, right? In this case, it's that URL. So I'm copying this over. I go to the exploit server, but on Chrome. So I go into the exploit server, I put this in here in the body, and then I hit store. right? And then what I can do is I can view the exploit. And then I see right now, you see this, I see it in the background. I still see the website in the background because of the opacity. So you couldn't send it like this, right? Like this is pretty bad, like because the victim would know, oh, there's something fishy going on. But the test me is far too high. So I want to align that test me with the delete account, right? So I obviously already know I need to get this down a lot further. I need to get this down in terms of pixels. So what about I'm choosing 685 pixels from the top instead? So I store this and then I reload it and see what's going to happen. And yes, this worked nicely, but now it's actually, I would say, it's probably too deep, right? Or yes, this is maybe we could try it. It's probably sometimes you're lucky, sometimes you're not. And by the way, in reality, you use something called Click Bandit to do this. This is too tedious, like this manual thing. I'm just showing you this for purpose of learning, right? So let's go back here, and it said in the description earlier that if we really wanna fish the victim, we have to put it to click me instead of test me, because the victim will only click when it says click me. In reality, this would be like win a prize or something like this. So let's store this, and let's also change the opacity, right? Like so that the victim does not see the actual underlying website. That's important because otherwise they know something bad is going on. And then we simply say deliver exploit to the victim. So we deliver that to the victim and it has not solved. Okay, so if it doesn't solve, then we probably need to rearrange our alignment of that specific code, of that specific click me functionality. And it also didn't do this here. And if we go further back and deliver it to the victim, then we have solved the lab. Okay, so basically this is a trial and error in many cases, and click checking is quite difficult because it depends on the resolution of the screen, it depends on the browser, it depends on a lot of browser settings and things like that. So you need to be aware of that. Even if it aligns on your test screen in Firefox or in Chrome, if the user is using Safari or another browser, it may not work. So this is important to understand. But purpose of this exercise is really like for you to get an understanding of how this works. And you can find these skeleton exploits all over the web, but they're pretty basic. They're not difficult to implement. And then you can do click checking attacks. Another important thing here is how to prevent this. And there's basically something called the X-frame options, which basically doesn't allow you, like if this is set server side, and if the server side is declining this, like for example your banking application has this option set, the X-frame options, what that means is it's not being allowed to be framed, to be iframed, so it cannot be used in click checking attacks. There's more advanced things to this. We will get to that in later videos in the practitioner section, but for now this is the basic click checking. Okay, thank you very much. Hey guys, this is Martin again, and today we will take a look at another lab called click checking with form input data pre-filled from a URL parameter. Okay, so this is an extension from the last lab we have done. This time we not just hit the delete button, but we actually want to change data in the victim's profile. Principles around it is the same, so please refer back to the previous video. We're going to access the lab, and we have been given parameters, Wiener and Peter, to see what's going on. Okay, so first and foremost, let's log on. Let's log in here and see what's happening in there. So we see there is an account, and we have the possibility to basically change the email address. So I go in and say test@test.com. There's CSRF protection on it, but CSRF protection is local. So that means if the victim is logged into the portal and is click checked, the CSRF protection doesn't really provide any protection, right? So we hit update email, and then we take a look what happened there. So let's go over to Burp and see what happened. So here was my test.com. There's the csurf token. But what I want to try is I'm going to send this to repeater, right? And let's say I change the request method. I change the request method from post to get. And then the csurf token pretty much becomes irrelevant anyway, so I can delete it. And then I go in here and say Martin at test.com, right? And then I resend this and see if this works. And it says method not allowed, okay? So I cannot change the request method. However, I may be able to pull off another trick, okay? And this is where click checking comes into play, because I have the victim basically click on that specific update button once it's pre-filled. So it is a post request. We know that now. A get request would have been too easy. It is a post request, but what we are going to do is we take a look at how to exploit this. So basically, if you take a look here, sorry, this is another screen. If we go over here, so this is my skeleton from before. So it's the same thing, iframe defined as at 500 times 700 pixels. The opacity, we changed this to 0.1 that we see what's going on. Later on, we need to change it back so the victim doesn't see the underlying iframe content. And obviously, we need to grab the URL. We need to grab the URL of the target application and replace that here in order to make sure. And what I'm going to do here is I'm loading an iframe, and what the iframe is doing, the iframe is going to that website, to my account, and then it's appending the email parameter. So it's pre-filling, basically. It's pre-filling the email field, but it does not submit it automatically. So here is where click checking comes into place, right? So this URL pre-fills it for the victim, but the victim then still has to click on the button in order to launch the post request along with the csurf token, if that makes sense. Okay, so let me take this exploit and put it in here in our exploit server. So let's head over to the exploit server. Let's put it in here and let's store it. Let's view the exploit, how it looks like actually. And you see there's this click me. Now, this doesn't make any sense at that point because we are supposed to be logged in. Okay, so this is probably a problem in, yeah, this is a problem by the looks of it in Portswigger, because I'm logged in right now and I'm in the same context, right? So what you should see is basically this account, and I do not see the account because I see the login here, right? So I see it still looks like it's unauthenticated, even though I'm authenticated here. So I can quickly verify this. Let's just refresh it one more time, or let's relaunch it. Give me just 1 second. You should be seeing this normally. So I'm storing this, and then I'm hitting view. And yeah, it still looks unauthenticated. In reality, like you've seen in the previous lab, it would look like it would show the click me button effectively within the change functionality of the email, right? So let's try something real quick. Let's just deliver this to the victim. Maybe this is a local problem. And if you deliver it to the victim, the lab is being solved. Okay, so there's maybe some technical functionality problem right now in the Portswigger lab, but not to worry. And it needs a lot of trial and error anyway. Click checking exercises always need a lot of trial and error because you basically need to take numerous factors into account. So if you looked at the exploit we sent, the arrangement in terms of where the actual text goes and stuff like that, this depends browser by browser. So some browsers may show it higher up, others may show it higher down. I explained this in the last video already, that different browser resolutions and things like that. But basically, this is a click checking exercise where you pre-fill the email field and then have the user click the submit button effectively. Okay, thank you very much. Hey guys, this is Martin, and today we have another click checking lab. This time it's click checking with a frame buster script. So effectively, the lab is protected by something called a frame buster, which prevents the website from being framed. So the previous two labs we have done would not work if there is a frame buster script, right? However, there is still possibility to bypass this, and our job really is to change the email address once again and click check the user. So we have been given administrative or user credentials, Wiener Peter, to log in. And that's what we are going to do now. Okay, so we are going to log in and see what kind of functionality we are facing there. It's pretty standard. Once again, I can change the email address, so I can put in test@test.com and update the email and then look at it in Burp. So what happened here, so this is my email request change, and it's pretty much the same thing. So it has a CSRF token, which is specific to that specific user. So if the user is logged in, then the CSRF token from that user will be used. So it's not really a protection mechanism. But basically, if you would use the previous iframe we have used in previous labs, that wouldn't work. So I have crafted here a little skeleton script once again. So we have our iframe, and the iframe has 500 pixels on 700 pixels. The opacity is set to a very low value. If you remember from the previous videos, this is how visible the underlying iframe website, like the victim website, actually looks like. So we want the victim not to see where they're actually clicking. We want the victim to see just like this button or this text, like win a prize and stuff like that. And then where this click me, this div here, where this click me is located in terms of the position of on the page, right? And now let me briefly just change the URL of the target application in here as well. And now you can see it's still an iframe. It's still an iframe, even though the standard iframe would not work, but I have another attribute in there, which is basically saying sandbox allow forms. And that is the so-called frame buster bypass. Okay, so by simply adding the sandbox equals allow dash forms, other than that, it's exactly the same like what we had before. And you see, we are going to pre-fill the email field with the email hacker@attacker-website.com. And then we need to click check the user to actually hit the submit button. Okay, so let's take this. Let's put it here onto the exploit server. Put it in the body, store it, and deliver that to the victim. And the lab is being solved. So basically, this is pretty much the same thing like what you have seen in the previous labs. You would need to play with the exact alignments, you know, like for example, the iframe size, but more importantly, where this actual click me button appears. So the position is very important, and that's highly browser dependent. So if I would now view this exploit, right? Like if I just look at this, well, I don't see anything. I just see click me because of the opacity. But if I change the opacity back to 0.1, store it again, look at view the exploit, then I would say this does not align at all, right? Like this does not align. But again, this is in Firefox browser, and the lab description said the user is using Chrome, right? So you would need to experiment with Chrome, and if the user uses Safari, it may be different again. And if they use, Opera or Edge or whatever, then you need to play with this. But this is effectively bypassing frame buster protection with an additional tag, with an additional attribute in the iframe. Okay, I hope this makes sense, and see you in the next video. Hey guys, this is Martin, and in today's lab, we will be taking a look at a CORS vulnerability with basic origin reflection. So what is CORS? CORS stands for Cross-Origin Resource Sharing, and which is effectively loosening the SOP or the same origin policy in cross-domain requests. So to understand this a bit better, the modern web applications often need to make call from one domain to another, and this is by default blocked in the modern browsers, right? So cross-origin communication is being blocked out, but CORS is loosening that, which makes absolute sense from a development perspective, because very often you have microservices and things like that where different domains need to retrieve information and talk to each other. But if it's configured incorrectly, it can be a serious security leak. And we are going to take a look at this right now. So first and foremost, we head over to our application and we log in. We have been given credentials. So we log in with the username Bina and password Peter. Okay, and what's happening, I have like my account portal here. Now let's take a look at Burp, what happened. And you see I made my post request, a 302 redirect, nothing special here. I load the account page, but then what's happening in the background as well is there is a call being made to get account details. And that account details is basically loading the API key which you see displayed. And so this is something called an API request in JSON. And so if I take this request now and send it to repeater, I can start playing with it. So obviously this request was made from the own domain, from the application domain. But what happens if I go in here and start playing with the origin header? So I say origin, and then I say https www.test.com. So let's try this out. And what you see immediately here is that it allows the access control allow origin to be test.com. So in other words, that means the domain test.com, or for example, the domain martin.com, or whatever I want to choose, is basically allowed to make an AJAX request. And what makes it worse is that the access control allow credentials is also set. So what that means is that the cookie information and the authentication information is passed along to the JavaScript. So because we are dealing here with an authenticated session, that basically means that the request will also pass along authentication credentials, right? So now that I know this, I can actually go over and start crafting an exploit and try to gain the API key from another user. So this is my skeleton exploit. It's just a basic JavaScript tag here. And then we are initializing it. We are making a GET request because we also did here the GET request to account details. So it has to be a GET request. That's the full URL to the vulnerable application along with the path of or the endpoint of account details, as you can see that here. And we are sending the credentials along equals true. And then basically what we want to do is we want to lock this locally. So /lock, and then with the parameter key. So I could give this any name, right? But this is basically, we want to lock this response. Once the victim has visited this specific malicious code, then it will be locked. That AJAX call will be made and it will be locked to our server. So let's take this and copy it into our exploit server here. Okay, so we are storing this, and now we send the victim a link. So you have this option on here, deliver exploit to victim. So in a real world scenario, you would simply send a link, or the victim a link to that specific web server. And when the link is being clicked within the context of the browser of the logged in session to that specific account details, then the AJAX call is being made and the key is exfiltrated. So let's deliver to victim, see what happens, and nothing obvious happened, but let's go to the access log. Let's check our access log, and if we go down here, you can actually see this is the victim IP address, this is the timestamp, and all of this was logged. So I copied the whole thing out, basically put it over to decoder in Burp to read it better, and then say like decode the URL, URL decoded, and then in there you see username, that was the administrator, the email, the API key. So here's the API key, which we have exfiltrated. I take it, and then I submit this here as the solution. And if all goes well, the lab should be solved. Yes. So this is a basic CORS vulnerability with basic origin reflection. Hope that makes sense, and see you in the next video. Hey guys, this is Martin again. Today we are looking at another lab called CORS vulnerability with trusted nil origin. So the problem here is similar to the lab we have just done earlier. Basically, CORS is misconfigured in such a respect that the nil origin is basically allowed. So the problem here is we cannot use the same exploit like we have done in the previous lab, because we were setting like the origin to anything.com, and then we were hosting it on the web server, and that had another domain, and that all worked fine because it was completely, everything was reflected. This doesn't work in that scenario, but there's still a possibility to exploit these kind of scenarios. So first and foremost, let's log in. Let's go over to the web application and take a look what's actually happening in the background. We log in with Wiener and Peter, and then we can see the API key is displayed. So it's pretty much the same thing as in the previous lab. There is the post send, and then after that we load the account page. But in addition to that, there is also this being loaded. So the account details, that call is being made, and it returns a JSON response. I'm sending this over to Repeater to play with it, and I do my standard test. So the first one would be origin, like we done in the previous video, HTTPS, and then www.test.com, and see if this works. And this time around, I see access control allow credentials true, but I don't see my own domain reflected, right? So this is not gonna work. So next test I'm going to do is I set this to the nil origin. And if I do that, I get the access control allow origin nil. So I now know that it's misconfigured and that I can make a call as long as the origin is set to nil effectively. So how do I do this? Like, how do I set this to nil? I cannot just put it on my server. And then because it will come with the origin of my own domain name. So, but there's a bypass for this. And if you look at the skeleton exploit here, it's basically you can use an iframe, and then as a sandbox iframe. So similar what we had in an earlier lab already around click checking, and it needs to allow scripts, allow top-node navigation, and allow forms, right? And what that basically does, I mean, it's really simple. It's almost the same request. What we are doing here with two differences. First of all, we have the sandbox. That is basically when scripts are being allowed effectively. So this is a script down here, and the script is an Ajax script. But also, when you run it from an iframe, the origin is automatically being set to nil. And that's important, right? But only when you launch this code from within an iframe. That's number one. But because we have a nil origin, we need to specify the destination where we want to lock our harvested credentials in full. Remember, like earlier, it was enough like just a / log and then the parameter. This is not enough in this scenario because we have a nil origin. So let's take this script, right? And then let's put it into our exploit server and see what happens, right? Like, so we put this here in the body, and then we simply store it. And once again, we deliver it over to the victim. And nothing has happened, or at least nothing obvious. But if we go to the access log, you will see that the victim actually made the call and it was successful. So you can see it in here. Once again, we take it over to Burp decoder, put it in decoder, and then this is the API key of the administrator, right? So we take it and then we submit this as the solution, and that should be finishing the lab. Correct. Another quick thing I want to show you, like if you ask yourself, like, hey, how do you come up with all these payloads and stuff like that? There's a really, really good website, which is like this book.hacktricks.xyz. And basically, if you browse through it, it has every topic around penetration testing and bug bounty hunting, and you find a lot of proof of concept exploits in there. Also a lot of theory, like if you want to reread the theory part. I mean, this course is really hands-on and it's really about the actual labs. But if you need to brush up on theory, how things work, how iframes work, and all these kind of things, and what kind of other attack vectors might be possible, this is a super good resource. So I highly recommend to go through that as well. Okay, that's it for today's video. I see you in the next one. Hey guys, this is Martin again, and today we are going to look at another vulnerability, exploiting XXE using external entities to retrieve files. So XXE stands for XML external entity injection, which is basically when you have XML input somewhere, you manipulate that XML input to utilize something called external entities, which normally should be blocked, but which are enabled by default unless they are blocked, and they introduce serious security risk. So in this lab, we have something called a check stock feature, which parses XML and then returns any values in the response. So we will have a play with this, and the ultimate goal is to exfiltrate the contents of the etc passwd file. Let's get started. We head over to our shop application. We see there is like nothing really on the homepage, no login, no nothing, just products, and we can see few details, right? So we can go in there, hitch a lift, and it's product ID number 1, and I can check the stock, right? Like, so if I want to buy this, for example, I can check, hey, in the Paris store, check the stock. And then what I get is they have 24 units of that specific product in stock. So if I head over to Burp, let's take a look what happened. This is the request I made. This is the post request to the stock endpoint, right? And down here, you see it is leveraging XML. So that's XML input. It's similar to HTML, but has a lot of differences. It used to be the go-to language many years ago for API calls, like especially around SOAP XML and stuff like that. It has been replaced more and more by GraphQL APIs and by RESTful APIs over recent years, but it's still around, right? So it's still a good thing to know. So again, I have prepared like a little skeleton exploit here. So doc type, I call the doc type simply test, and then I call the external entity, which I name after me, like I call it Martin, and then I call the system functionality within the entity, and I instruct it to get me that content of that file, right? So I take this and I simply put it in here like this, but this is not working yet, because what I still need to do is I need to actually instruct, I need to display this on the page, right? Or I need to ensure that I get the visible output. Like if I would send this right now, it doesn't work. It's basically, I still get 24, right? So what I need to do is I need to go into the product ID or store ID. It always depends on the application, so you need to try around, but basically it's and then the name of the specified entity, which was Martin, and then this, right? A semicolon. And we hit send. And what happens is, see, invalid product ID, so it had thrown an error, but it revealed the details of the etc passwd file. And you can use this for all kinds of things, and in future labs, and especially in the practitioner labs, we go much more into detail. So that's a very, very basic XXE injection against an application. Hope that makes sense, and see you in the next video. Hey guys, this is Martin, and in today's lab we are going to exploit another XXE external entity injection, but this time we leverage it not to retrieve contents of the etc passwd file, but we leverage it to retrieve information from an EC2 metadata endpoint. So a lot of cloud is being used. So EC2 is Amazon AWS. A lot of cloud is being used these days, right? And there is a default URL, which is basically this one here. And we try to retrieve interesting content from there. Now, first of all, we haven't talked about SSRF attacks yet, but SSRF in a nutshell is basically if you manipulate your query to an application so that that application is going to further query either itself or another internal system which you could normally not reach. Like this is a perfect example. If this is not routed, right? Like if you would try this in a browser, it wouldn't work. It's the same like to the 192.168 private address range, or the 10.x.x.x private address range, and so forth. So you're basically leveraging the application to make a call on your behalf. That's basically what SSRF is. But we have a full video series on that later on. But let's head over first and let's check our application. So it's similar application than before. Effectively, I go to the first product, and then I again have my check stock feature. So I've just selected London. And what I can do here is I send this over to repeater, and in repeater I see, hey, there's XML input, so maybe I can launch an SSRF attack, right? So I prepared a payload here. Again, we are calling an external entity, which normally should not be the case, but instead of having the file command in here and reading a local file, we are actually going to this EC2 instance, right? So let's put this in here and see what happens. Let's put it in, let's hit send, and we don't get any new response. And that's for the reason because we need to actually also call that newly defined entity here in the product ID as before. And now I get an error message. So it says invalid product ID latest. So my next thing is, okay, so latest, maybe I put this here in the path, right? And see what happens. All right, excellent. So now I get a different error which says metadata. So maybe this is like a long path. So I use metadata here and hit send. All right, so now it's saying IAM. So step by step, you can actually browse yourself or SSRF yourself towards the interesting portions of this. So security credentials, now we're talking here, right? Security dash credentials. And then let's hit send again. And then admin, that's even better, right? So admin credentials. And here we go. So now we actually have successfully launched an SSRF attack through XML, and there's a secret access key, and I guess the solution is looking for that. So let's grab this, go up here, and it's already solved. So there's no solutions button this time, like to submit it, because we have already now successfully exfiltrated secrets via an XML attack through SSRF. I hope that makes sense, and I see you in the next video. Hey guys, this is Martin, and in today's lab we look at a basic SSRF, server-side request forgery, against the local server. So what is SSRF? SSRF is effectively the technique when you are able to manipulate an application to make further requests and further calls on your behalf. Like an example for this would be if I want to get to the local interface, like to the loopback, to the 127.0.0.1, I can enter this in my local browser, fine, but I will only get to my own local loopback, right? But maybe I want to abuse the web application and maybe I want to browse to the local machine itself or to another internal machine, like a 192.168 or a 10.x.x.x or any of these kind of IP addresses. And then maybe the security restrictions are a lot lax as well because the request is effectively coming from an internal application. So that is SSRF in a nutshell. And in our lab here, basically there's a stock check feature which fetches data from another internal system. And our job really is to access the admin interface and then delete the user Carlos, right? So let's head over to the lab. And first of all, let's check out the stock check functionality. I go to a product, I check the stock for London, and then I see there's 474 units. And if I look at this request, basically, let's take a look at this. I see down here, there's the stock API and there's a URL being parsed, right? So I can highlight this and then it shows me, it basically decodes the URL for me here in Burp. And I see that this is going to something called stock.weliketoshop.net, port 8080 and so forth. So now my first question is, can I actually get to the admin interface like as a normal user, as a regular user? So if I go here and say like admin, and then it will say like admin interface is only available if you're logged in as administrator or if requested from the loopback. And the loopback, as I mentioned earlier, is the 127.0.0.1 or also referred to as localhost, right? So what happens now if I replace this URL and say HTTP 127.0.0.1 and /admin. So now I'm not making the call directly, rather I have the application make the call for me to this URL, right? And I hit send and I get a 200 OK, which is great. I can render this. And now you see, hey, I'm in the admin panel. I actually managed via SSRF to get to the admin panel. And there's 2 users in there. There a Wiener and a Carlos. And now my job is to delete them, right? So I look at something called Carlos first. So I look at Carlos and then I see here, hey, there is an href tag, basically admin delete. So if I would click that button, right, which I cannot because I cannot access it locally. So I need to figure it out if there's another way that I can actually make that click action happen in other means. And effectively, basically, I now know that it's called admin / delete. And then I need to specify a parameter, which is the username. So the source code gives me everything here, equals Carlos. So if I send this now, then I get a 302 found. And if I follow the redirection, then I get an unauthorized because I'm trying again to access the admin interface, but this time via the normal host. So this obviously failed, but the lab was solved. So if you go back here, the lab is solved because I was able to actually delete that user Carlos through the call, through the stock check feature, which basically took my URL. So I was able to manipulate that URL. So it's very important always as a developer to not allow user controllable URLs for features like this. Okay, I hope this makes sense and see you in the next video. Hey guys, this is Martin, and today's lab we take a look at another basic SSRF or server-side request forgery against another backend system. So in the previous example, we instructed the StockCheck API to make a query to itself, to the own server. This time around, we are going to take a look at other internal systems. So again, this is very valuable because I could not access a company 192.168 range, right? Because this is a private network which is not routed on the internet, and effectively tells me there is another admin panel on the internal, and it's running on port 8080, and my job is to access that and then delete the user Carlos. Let's head over. Let's go to any product here. Let's go to the first product and then use the stock check functionality, which gives me the number of items in stock. Let's use this. Let's put it in here into repeater, and then you can see this is the URL. So the call it's making is to 192.168.0.1 on port 8080 product, and so forth and so forth. But let me change this to HTTP, and then if this is user controllable, like .1 for example, right? And then port 8080 /admin. So let's see if this works. And this does not work, right? So I get a 400 bad request, and what I'm going to do now is I'm going to send this over to Intruder, and simply to automate this, because otherwise it will take ages to do this one by one. And what I'm going to do is I set the payload position here of what I want to change per request. In this case, it's the number 1, and then number 2, 3, 4, 5, and so forth. And in the payloads, I simply use a numbers list, and I run this from 1 to 254, step 1, and hit start attack. So now it's sending like 254 requests, and we will see what happens. So once this is done, I get a lot of 500 server error messages, right? Here, like internal server error. I can sort by status. And interestingly enough, there's only one which came back with the 200, with 200 OK, and that's the number 118. So seems to me that this was successful. Let's send this back to repeater. And then in repeater, I simply send that request and render it and see what's happening. And there we go. So I was able to successfully access an admin interface on 192.168.0.118 on port 8080, right? And now I can look here for Carlos, for example, and then I see what the href is when you would click there, like in order to delete this username. So here you get the syntax. It's /admin /delete, append the username equals Carlos, and then we simply hit send, and I got a 302 found. If I go to the website here, I have solved the lab successfully because Carlos is no longer a user. So I can verify this as well by simply browsing to the admin interface and hit send, render this, and then I see that there is only Vina left now. Carlos has been successfully deleted. I hope this makes sense, and I look forward to see you in the next video. Hello everyone. Today we take a look at another vulnerability, OS command injection, a simple case. So what is command injection is if you control input to the application or to the server, and you can basically enter system commands, right? Which are then being taken by the system or by the application, and these could be like Linux commands, this could be like Microsoft commands, completely dependent on the operating system, obviously, but it's effectively controlling that machine or that application by introducing system commands. And this is usually a critical vulnerability because if you can issue system commands, you may be able to evaluate privileges and things like that, or you may take full control over the target. And today we are going to take a look at one of these vulnerabilities. So there's an application basically which provides or which accepts user supplied input, and so the product and store IDs, but there is a vulnerability whereby you can actually introduce system commands. Okay, so let's get started. Let's take a look how this looks like. This is our shopping application. We go to the first product. We see down here there's a check stock option. So if I click this, I basically get the response. The normal response is like there's 62 units in that store. If I go over to Burp and I take a look at this, I send it to Repeater to play with it. And you see there's like a store ID and a product ID. And what I can now try to do is basically, so I can use like the pipe delimiter, which is a Linux system command. And then I can put in like who am I, which is basically like a Linux system command. And you see, immediately I get the response called Peter. So that's basically who am I. If I would put this on the CLI, on the command line, I would get the same result. I can probably do other commands, like for example, an ls, a list, and then you see that the folder directory here of that specific folder you're in. You could probably do an ID as well, and then that gives you like the ID, including the UID number and things like that. That's a basic example with no filtering, and you are simply able to launch system commands directly from the command line. I hope that makes sense, and I see you in one of the next videos. Hey guys, this is Martin, and today we will look at another vulnerability type. The lab here is the file path traversal, a simple case. Okay, so file path traversal effectively means that you as a user can control the directory structure. So you are effectively supposed to, say, view a picture in a certain directory through an input parameter, but you are able to break out of that directory and access other directories which you're not supposed to access, right? It's also referred to as directory traversal in other documentation. And today we will take a look at one of those scenarios. So we are launching the lab here. And so the goal really is, the lab contains a file path traversal vulnerability, right? And it is in the display of product images. So these product images are loaded from somewhere, and our goal is to retrieve the contents of the etc passwd file. So we already know by that it's a Linux system. The same applies to Microsoft systems as well, but then it would not be the etc passwd, but the WinINI or whatever, right? So let's head over to the lab. And you can see here what's happening is you have these pictures. So if I take one of those pictures and say like open image in new text, so in new tab, I'm basically seeing, hey, here's my URL, here's my domain, here's the folder. And so it's the image folder, and then there's a parameter, and it basically says file name equals 30.jpg, right? So let's take a look at this in Burp. And if we don't see this in Burp here, there's a reason for this, because you can actually, like by default, images are not shown. So you have to apply this, and then you get the image here as well. So I sent it to repeater, and normally you don't want to see images in most cases. So I turn this functionality off again. But basically I have it now in repeater, and this is the request I sent when I was loading the picture, right? And you can see if I load the picture, it basically shows me the content over here, like JPEG content type image JPEG. Okay, so the first thing I would do is, so I'm in the image folder, so I can introduce a path traversal sequence. So I do a // which means that brings me back one folder up in the hierarchy, right? And then another one and another one. So I just want to make sure that I jump back to the root, right? Like if you look at the Linux file system, you have like all these subfolders and subfolders and subfolders. And so you can put like 5 or more in there, just to make sure that based on the file system that you actually end up in the root directory. And then once you're in the root directory, you go into the etc directory, and then the path.wd file, right? Like this. So this is like the path traversal sequence, and then this is the final folder where we want to get into. So if we launch this, I get my results. So I was successfully able to do a path traversal, a directory traversal attack, and I'm able to view the contents of the etc path.wd file, as you can see this here. If I go back to the application, I should see that the lab has been solved. Okay, this was a simple case, and I look forward to show you more of these in upcoming videos. Thank you very much. Hey guys, this is Martin, and today we have a new topic. This time we are in the access control vulnerabilities. So the first lab here is unprotected admin functionality. So the lab has an unprotected admin panel, which can be just browsed to. It's not linked on the page, so we have to find out how to get to this, but this is a vulnerability, a basic vulnerability I'm going to show you today. So the task is basically, first of all, we need to find that unprotected admin functionality, or that unprotected admin panel. And then we need to delete the user Carlos in order to finish the lab. Okay, so let's head over, and one thing I can try is just a /admin and see if that works, and it says not found. Okay, it's not there. So you can start brute forcing around and things like that, but what I typically do and what's common practice is you start out with the robots.txt file. Robots.txt file is simply like a text file for search engines, like for the Google bot, for the Bing bot, for the Yahoo bot, to tell the search engines what shall be indexed on the search engine and what shall not be indexed. And if I look at this, I see, well, it's accepting any user agent, so any search engine is welcome, but please do not index the administrator panel. So from an attacker's perspective, or from a pen tester's perspective, this is obviously something I'm interested in, because anything they disallow is probably of value. So what I'm going to do is I'm simply pasting this here and see if I can get to this. Okay, and here we go. So I have now access to the admin panel, even though I'm not authenticated and I'm not logged in or any of that. And then I can delete the user Carlos. Okay, and that solves the lab. That's a very basic unprotected admin functionality vulnerability. I will see you in one of the next labs. Thank you. Hey guys, this is Martin again, and we are in the access control vulnerability section. Today we are looking at an unprotected admin functionality with an unpredictable URL. Okay, so if you recall from the last video, we analyzed the robots.txt file, and the robots.txt file actually gave us the result. So if we try the same here, robots.txt, nothing found. So there's no robots.txt file, and as the lab description already mentions, it's an unpredictable URL. So it's probably not something I can brute force or I can guess easily or stuff like that. So one thing you can do is you head over to Burp and you simply send the GET request to the homepage to the repeater, and then you send that request. So we are going through the source code now, right? So maybe there's a hint or there's something in the source code. So first thing I'm searching for is something called admin. And then, yes, I get the title. Obviously, this is not what I'm interested in. I have 11 matches in total. And then I get an H2 tag as well, which is again the lab description, not interesting. There's an admin keyword in the URL itself, but now we are getting somewhere, right? Like, so here you can see this is a script, a JavaScript, and there's a variable defined called isAdmin, and there's a lot of references to admin. So if we go through this one by line, we will find something, which is this one here, admin panel tag.set attribute href, which is a link, and then you find something like this in here, right? So it's /admin -1EMUHN. So interesting. So let me copy this out and go over here and put this in the browser. And here we go. So basically, I was able to find the admin functionality by simply going through the source code and looking at links or references to admin. In order to solve the lab, again, we have to delete the user Carlos, and that solves the lab for us. I hope this makes sense, and I look forward to see you in one of the next videos. Hey guys, this is Martin again, access control vulnerabilities, and today we are looking at the user role is being controlled by a request parameter. Okay, so the lab has an admin panel at /admin, which identifies administrators by setting a forgeable cookie. So what I mean by that is there is a cookie being set, which is forgeable, which is user controllable. And in order to solve the lab, we have to access the admin panel and we have to delete the user Carlos. We can log into our own account with the credentials Wiener Peter. So I'm heading over to the application and go to my account and I log in as Wiener and Peter, right? And so I'm logged in and nothing special here, no admin privileges or any of that. And let's head over to Burp and see what actually happened. So something interesting happened, right? When I logged in here with my username and password, there's a 302 redirect, but you can see two cookies are being set. One is being set as the session cookie, and another one is being set as admin equals false. And then you see, like in my subsequent request to the get my account, the admin is being set to false. So what happens now if I set the admin to true? And let me tell you, I can do this easily here in Burp, but because I probably need the cookie set on subsequent requests as well when I delete the user Carlos, I head over to the browser and I go to something called the cookie editor, okay, which is basically an extension to Firefox. And then here you can see this is the admin cookie, and it's set to false. So let me set this to true, save it, and then reload the page. And all of a sudden you can see there is an admin panel which appeared here, right? Because now the application thinks I'm an admin because I have the admin cookie set to true. So I head over to the admin panel and I delete the user Carlos, and that solves the lab for me. So this was a basic example of cookie manipulation because the cookie is user controllable and you simply set it from false to true. I hope this makes sense, and I see you in one of the next videos. Thank you. Hey guys, this is Martin again. We are in the access control vulnerability section, and today the lab is user role can be modified in user profile. So the lab has an admin panel located at /admin, but it's only accessible to logged in users with a role ID of 2, right? So our goal is basically to access the admin panel and delete the user Carlos. We have been given credentials, presumably for a normal user account, and we will now start to analyze the application. So if we go to the application and we simply enter /admin as a non-authenticated user, it will say like, hey, it's only available if you're logged in as an administrator. Okay, so it doesn't work. Let's go to our account and let's log in with our credentials, Wiener and Peter. and we get into our account settings here. Next test I'm going to do is I'm simply trying again from a logged in user this time, although not an admin. Can I reach it? No, it's again the same thing. So what else can I do? Well, there's not many options. I can only change the email address, but let's change the email address to test@test.com. Update that, and I can say martin@martin.com or whatever, right? Like, so you see it successfully changed it. Let's head over to Burp and see what happened in this request. So first thing you should be able to see here is that there is no admin cookie, like admin false, admin true, like in one of the previous labs. So that's obviously not an option. There's just a session identifier. But when I basically send this request over, there is certain information returned to me. When I change the email address, I get in the response, in the JSON response, Wiener, the email address, and the API key, but also something called the role ID. And that's interesting because role ID 1, I presume, means regular user versus role ID 2 means privileged user or administrator user. So what I'm trying here is I simply add in the JSON, I add something called a role ID, right? Role ID, and then the role ID is going to be true. So this was not intended, or the developers haven't intended this, but sometimes this works, and sometimes you can actually change things you're not supposed to change. So I hit send, and then all of a sudden see, hey, this worked because the role ID is now set to true, right? So I was simply mass assigning like another parameter with a value, like a key value pair, which wasn't there by default, but I was just fiddling with it. So maybe I could also change the API key. Maybe I could change, like the username or something like this. But the role ID is really key in this respect. So I'm going to refresh the page, and you see all of a sudden I have the admin panel at my disposal. So I go to the admin panel, and I can now delete the user Carlos. So this was a simple example of modifying, a role ID by simply, introducing that role ID, even you're not supposed to introduce that. I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin. We are in the access control vulnerability section, and today's lab is user ID is controlled by a request parameter. So the lab has a horizontal privilege escalation vulnerability on the user account page. And in order to solve the lab, we need to retrieve the API key of a user called Carlos and then submit this as a solution. We can log into our own account with the credentials Wiener Peter. Now, horizontal privilege escalation means you're able to access something from another user which is at the same privilege level as you. Like, for example, one staff user can access something from another staff user or something like that. Versus a vertical privilege escalation means that you can actually obtain information or do functionality which only a higher level or higher privilege level user like an administrator will be able to do. So this is just for your information. Let's head over to the application and let's log into our account and see what's happening, right? So we log in with Wiener Peter, and we see there is an API key presented. So this is our own. So if I submit this is obviously not the solution because we want to retrieve this from another user called Carlos. Let's head over to our login. So we see we have done our login. It's all pretty straightforward and nothing really stands out at that point. So we can browse around a bit and then head back to our account page. And basically something which you will notice in Burp is there's a GET request being made, right? So there's a GET request being made when I browse around, and the GET request says Wiener, right? So this is interesting. So it says ID Wiener. And if I look for the API key here, you see your username is Wiener and your API key is this API key. So what happens if I change this ID to, say, administrator and then hit send? And then all of a sudden, I see your username is now administrator and the API key is that API key. But that's not the one we are looking for. We are actually looking for the one Carlos, right? So you can see the ID parameter here is user controllable and doesn't perform any authorization checks on whether I'm actually logged in as that user in order to query that information. So here's our user Carlos, and here's the API key. So let's copy that and let's head over to the web application and submit this as a solution. And that basically solves the lab for us. I hope this makes sense, and I see you in one of the next videos. Hi guys, this is Martin again. We are in the access control vulnerability labs, and today's lab is the user ID controlled by request parameter with unpredictable user IDs. So pretty similar to the previous lab we have done, with the difference that this time around they're not using predictable user IDs like Carlos and Vina and stuff. This time they're using so-called GU IDs. And that makes it more complicated. And a lot of companies use those because they are not really easily brute forceable. But there are still ways around this. And in this lab, we are going to take a look on how to bypass these restrictions and what to look out for and things like that. So in order to get started, we have been given credentials as Vina Peter, and we are going to log in with them. Okay, so let's head over here. Let's log in with Vina Peter. And we browse around, same like we've done this in the previous lab. If we head over to Burp, we will basically see that there is, again, a request parameter being used, but this time around it uses like something like this, which is a GU ID, which is much, much more difficult to predict and to brute force effectively. So I could try this now, but the chances are pretty slim to actually brute force one of those. So what else can we do? Well, basically, sometimes these GU IDs are leaked unintentionally somewhere else. So let's head back to home, and you see it's a blog, right? So if I browse around here in the blog and I go to the first post, for example, I see that an administrator was doing this, right? And if I do a mouse over, you see in the bottom left corner, hey, there's the user ID for this administrator. So there's a vulnerability, as in the developers didn't think about it, that, well, they didn't think there's any harm of disclosing those in the blog posts, right? But there is actually harm, because now I can chain this together. I can take this GU ID and then use it in order to retrieve the API key of someone else. But this is not the guy I'm looking for. So I'm not looking for administrator, right? I'm looking for the lab asks me for Carlos. So I go to the next one. This is from administrator again. And I go down to the next one. And this is from Vina. This is from myself, basically. And what about this one here? Oh, this is from Carlos. Okay, so let me copy this link out, right? So that you get to see it. So this is basically the link, and here is the user ID. So this should be the user ID for Carlos. This would have been unpredictable for me to brute force, but thankfully it leaked somewhere else on the application. So I'm going to take this, replace it here, and resend the request. Now I look for the API key, API, and then I can see here username is Carlos, and that's the API key of Carlos. Let's copy this out, head over to the application, submit the solution, and that will solve our lab. I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin again, and we are in the access control vulnerabilities. So today's lab is the user ID is controlled by a request parameter with data leakage in a redirect. Okay, so similar to the previous labs, but the developers tried to tackle certain vulnerabilities which we encountered earlier, but they still made a mistake which reveals the API key. So let's head over to the application, and as usual, we log in with our own credentials, which we have been given as in Vina and Peter, and we can browse around here, and we simply go back to our profile. Let's take a look in Burp, and you can see this is like one of the similar labs we have done earlier. There's basically the get my account, and then the request parameter equals Vina. If I send this, it works, and I can look for API key, so Vina and my API key. But that's me, that's my own account, right? So I want to change this to Carlos. So I'm changing this to Carlos, and then you see I get a 302 redirect. So a 302 redirect to the login. So that basically means, hey, you're not Carlos. I make an authorization check here that you are not Carlos, you're Vina. But you are requesting the information from Carlos. I send you back to the login page so you can log in as Carlos if you're really Carlos. Okay, so that's the logic behind this. However, in the 302 redirect, as you can see this in Burp here, you wouldn't see this on the page. You only see this like when you proxy through Burp. You can see that the username is Carlos and the API key was leaked. It was leaked in the 302 redirect. So I just show you this real quick in the browser, how this would look like. Like if I change it here from Vina to Carlos, you are being redirected to the login page and you don't see any API key or any of that. So it's not visible on the front end, but it is visible within the 302 redirect, as you can see here, right? So I copy this key out as usual and submit it as a solution, which effectively solves our lab. I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin again. We are in the access control vulnerability section, and today's lab is the user ID is controlled by a request parameter, as before, with a password disclosure. So basically, the lab application user account page has a functionality which allows us to retrieve anyone's password and then log in as that person. So we are heading over to the lab. We have been given credentials as Vina Peter to access our own account. And the goal really is, like, first of all, to retrieve the administrator's password, log in as that administrator, and then delete the user Carlos. Okay, let's do that. Let's head over here and log in with Vina and Peter, right? And then you see the admin panel this time looks different. And you see there's a functionality called update password. Right, so the password is masked out. I don't see this, but this may be a client-side UX protection. Okay, so let's simply hit update password. Right, so nothing happens. I haven't seen anything, but if I head over to Burp, what happened here? So what effectively happened here? So what I see is that I can now see the password in clear text, right? Even though it was masked out, but what the developers failed to do is to actually prevent that functionality on the within the proxy traffic. So it's a pure UX client-side control, right? So this is interesting. This is certainly a vulnerability. So let's go back here, and I can also change the ID here to administrator. Right? So I'm saying here ID administrator, see what happens. And then all of a sudden it says, hey, your username is administrator. Fantastic. And there is the password, but I cannot see the password. But what if I don't change the password and just hit update password? And then I head over again and look at this specific request. And this was the one for the administrator. And then all of a sudden you can see the administrator's password here. So let's take this. Let's head over to my account. Let's log out of the Vina account. Let's log back in as the administrator with the password which was just leaked. And that gives you access to the administrator account, and including the administrator panel where we delete the username Carlos, and that solves the lab for us. I hope this makes sense, and I see you in one of the next videos. Hello guys, this is Martin again, and today we will be looking at another access control vulnerability. This time around it's insecure direct object reference, also referred to as IDOR, which effectively means you can get to information you're not supposed to get to. And it's failing to do an authorization check. It's usually based on ID values and things like that. I think what's important to mention is an IDOR is not just on a GET request. So an IDOR can also exist like on a delete request, that you can delete other resources or you can add other resources which you're not supposed to do from an authorization perspective. So this lab here stores user chat logs directly on the server file system, and then receives it using static URLs, okay, which is a vulnerability in its own. We will be taking a look how this actually works. So you can see here there's a live chat functionality. If we go to the live chat and then we say, hello, customer support or something, custom support, send, and then could you spell that please, or I'm talking to customer support. And now what I can do is, the other option I have is view the transcript, right? So I'm going to view transcript, which is basically then downloading that transcript, like the chat history of my conversation, through the local file system. So if I go over to Burp, I see there was a GET request being made. There's a GET request being made, which is this one here. Let's send this over to repeater. And so this is the chat history. Hello, customer support. This was my message. And then the customer support responded back. So what I immediately see is, hey, it's loading a text file. It's just a plain text file. What happens if I change that ID? If I put this to 3, which is probably returning nothing because there's no transcript. So logically, if I have transcript number 2, okay, then there must be something called transcript number 1 because that was the previous one. So I'm going to send this, and here is your IDO vulnerability. So I can actually access other people's transcripts, which were not my chat histories. So that's a vulnerability, and that's a classical IDOR. And you can see here, if you read through this, that they were, so someone was discussing here the password reset, right? So let's have a look through this. Like, hi, Hal, I've forgotten my password, and blah, blah, blah. And then Hal says like this, and yeah. And then here's, okay, so he's being convinced to give out the password. So I'm copying this password, and I know, for example, for a fact that this was a chat history of another user, right? And I can now take this password, and then I go to my account, and then I log in as user Carlos with that password because Carlos has forgotten that password, and I solved the lab. So basically I was able to retrieve chat history from Carlos with customer support, where he basically asked for the password because he forgotten it, and then that was visible in the chat history. Okay, I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin. We are in the authentication vulnerability section, and today we'll be looking at a lab called username enumeration via different responses. So basically there's a login functionality, and the lab is vulnerable to username enumeration. What that means is that I get distinct error messages based on the username I supply. Best practice here is normally that you get generic messages, so users cannot enumerate, or attackers cannot enumerate which are valid users and which ones are not. And that allows for brute force attacks if there is no rate limiting in place. So we've been given 2 lists here from Portswigger. One is a usernames list here, and one is a passwords list. And we are going to access the lab, and the lab is subject to this username enumeration. We will be going through step by step on how to exploit this and gain access to a valid user account. Okay, so first and foremost, let's head over to the lab. Let's go to the account page, and let's simply type in test and test, right, or something like that, and then log in. And so immediately what I see is I get a distinct invalid username message, which is not good, right? Because that means if I can now type in multiple usernames or different usernames, then I might get a different error message. So what I'm going to do first is I head over to Burp. I send this post request to something called the intruder. And the intruder is like a brute forcing tool where you can send multiple requests like in sequence, and this makes your life easier. So you first of all choose the value of the parameter username which you want to send the payloads in. So basically this one here, and then I want to send like all my username list, and the username list is here. So I'm copying the lab usernames all the way down up until here. I copy those, I head back to intruder, and I go into payloads. It's a simple list, I paste it in here, right? So those are the usernames. And then a nice feature you have is that you can basically go to your settings, and in the settings you have something called grab match and grab extract. So we are interested in extracting that error message, because what my gut feel is basically that we set like username, right? Like username, it doesn't exist or something like this. So if we scroll down here and let's just refresh the response real quick. And let's see what the error message was, because I want to grab on that error message. This is the error message, invalid username. So this is simply to visualize in my output columns whether the username is invalid or whether I get a different error message. So I'm using this, and then I launch my attack. So my attack is now being launched, and you can see here there's a lot of 200 requests, and all of these have the invalid username in there, right? So if I now sort by this column, I see there is only one response, which was request number 75, where the payload was application. So the username is application and it says incorrect password. And that's exactly what I'm interested in, because now I have enumerated successfully a valid username. And I'm going to resend this to intruder again. Okay, but this time around, I know that the correct username is application. So I want to brute force the password. So I do the same thing, but this time on the password parameter. I go into payloads, and then I'm copying all the provided password lists. So in a real world scenario, your password lists will be a lot longer and things like that. So you have like sec lists out there and things like that. But for demonstration purposes, this is absolutely sufficient. And I paste this in and then I run the attack. So you see it's 100 different passwords I'm now trying against that valid username. And they all pretty much look the same, so there is no real difference. But if I change the status column, I will see that there was one request 38 where I got a 302. And that looks to me like this is probably the correct password. So in order to find this out, I will then simply right click here and say show response in browser, and then copy that, go over to the browser, go into my lab and load that. And here we go. So we have successfully accessed now the username application, and we are logged in as the application user in that specific scenario. I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin, and we are in the authentication vulnerability section. Today's lab is a 2FA simple bypass. So the lab uses two-factor authentication, but it can be bypassed. And let's assume you already obtained a valid username and password, but you do not have access to the user's 2FA verification code. There is, if misconfigured, there's various bypasses to that. And today we are going to look at one of them. So first and foremost, we have given two credentials. Basically, one is our own, Wiener Peter, and we have access to the 2FA code via email. And the other one is the victim credentials, Carlos Montoya, where we don't have access to his email in order to get the 2FA code. So let's first run through the login functionality with my own credentials. So I'm entering Wiener Peter. So that's myself, and then it's asking me for the code, and I go to my email client. Okay, so this is my email inbox, and I see like your security code is 1127. So I copy this over here, and then hit login, and I will be logged in basically. So I'm at my account page here, right? Like so, my account, and so I'm effectively logged in. Okay, now let's log out. Okay, and now let's try to exploit the 2FA flow for Carlos. So his username is Carlos and his password is Montoya. And now I face the problem that I do not have access to his 4-digit security code because I only have access to my own email, right? But not to the victim's email. So sometimes this can be bypassed by then simply browsing directly to the My Account page. And in this case, that worked. So what happened is the developers did not foresee the fact that once you're logged in with your username and password, that even if you don't supply the 2FA code, that you are already logged in from a machine state perspective, right? So we were already logged in, but it still prompted us for the 2FA code. So if I would have entered the correct 2FA code, I would have been redirected to the same page, to the My Account. But if I browse directly to the My Account after supplying username and password, I had the same effect. So that's a very simple 2FA bypass, which sometimes works, and I have actually seen this in bug bounty programs myself. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin again, and today we are in the authentication vulnerability section. Our lab today is password reset broken logic. So there is a reset functionality which is vulnerable, and to solve that we basically need to reset Carlos's password and then log in and access the account page. So first and foremost, we are firing up the lab, and at the same time our credentials have been given, so this is useful, so we can actually run through the password reset process with our account first, and then we see where the vulnerability is. So basically I go to my account, say I have forgotten my password, but I know my username, which is Vina, and then I simply hit submit, right? And then now it says like, please check your password for the reset link. Please check your email for the reset password link. So we go in here, we go to our email account, and then I can view this in raw format to make it easier to read. And this is basically our reset link, right? So we take this reset link, we put it in here, and then it's prompting me for a new password. So I want to say Vina, for example. So Vina, again, submit, and that's it. So password has been reset. So I'm going in and see if that worked. And that worked, right? So no problem here. But something you can see already is I spotted something interesting. I don't know if you have seen it, but now let's request a forgot password again. So number one, I'm going in and say Vina. So this is for me again, and it's asking me for the password reset link, right? So, okay, I'm going back to my email account. I'm going back here to my email account, and I should have received a new password reset link. Okay, so I click and open this. But now something I've seen here is basically there is a hidden field called username, right? And what if I change this to Carlos, right? And then I set the new password to Carlos and confirm that. And so there's actually two vulnerabilities. Number one is that token is not checking for which user it was issued. That's number one. So I can leave this token in, even though it was generated for Vina, it will still work for Carlos. Or I could remove it altogether. I could remove the whole value, and then it would still work, right? So I'm going to submit this, and I didn't get an error message. And now I go over to my account and I try to log in as Carlos with the password Carlos, and it worked. So I was able to successfully reset someone else's password. Okay, I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin. We are in a new section called WebSockets. And our first lab here is manipulating WebSocket messages to exploit vulnerabilities. So first and foremost, what are WebSockets? WebSockets effectively are initiated over HTTP, and they provide like long-lived connections with asynchronous communication in both directions. It's heavily used in modern web applications and things. You see them, you come across them all the time, like with customer support, chat functions, and so forth. Although they are built on the HTTP protocol and they're a separate protocol, most of the web application vulnerabilities apply to them as well. So in our first lab here, we are going to start a chat program with a support agent in real time. And then basically to solve the lab, we introduce a cross-site scripting vulnerability in order to pop up in the support agent's browser, like on the other end. Okay, so let's get started. Let's move over to our live chat here. And I'm simply typing in a message, say hello, for example, and then hit send. And then the support agent response. Okay, so what happens if I put in like a script tag or something like that, right? With angle brackets. So I don't see anything at that point, but I go over to Burp, and what you will notice is you will not see those messages in the HTTP history. You have to go over to the WebSocket history, right? And in the WebSocket history, basically, you can see this request. So this request was my script tag, and what you can clearly see, I send it over to repeater. What you can clearly see, it was encoded, right? So you see the percentage LT, semicolon, and the GT, sorry, not the end GT. So this is basically encoded. So it takes some precautions. However, this might be encoded client side only, right? So when I enter it in the chat box, but I can replay this message, and let's try to introduce like a cross-site scripting payload, but through the actual web socket message sending functionality. So if I say IMG SRC, so IMG source, so I'm loading an image from an unknown source, and then I say on error, which will obviously trigger, equals, and then I can, for example, say alert 0, right? Something like this, and close the script tag. And if I send this over, I can see that it was actually processed. And if I go to my browser, I can see that it actually fired. So it fired on both sides as well here, as well as in the browser of the support agent. And by doing this, you effectively introduce a cross-site scripting vulnerability. So the lab still shows as not solved. I don't know why that is. We obviously triggered it already, so I can resend it again here. And this may be a problem from on the port trigger side, but no worry about it. This is how to exploit it. Okay, I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin. We are in a new section. Today we are talking about modifying serialized objects. So the broader topic is insecure deserialization. So data structures are often serialized, deserialized when they are being transported from one application to another, simply to make it more efficient. But if the object is user controllable and the server does not do certain checkings and validations, it's basically possible that that you are modifying a serialized object and you inflict behavior which the application developer has not intended, right? So we have exactly that case scenario here. We have been given credentials for Wiener and Peter, and there is a serialization-based session mechanism in that vulnerable web application which allows for vertical privilege escalation. So we are going to access the lab, and first of all, we are going to log in. So we have been given Wiener and Peter as usernames and username and password. So we are logging in. And first thing I'm going to try is, hey, can I actually access the admin functionality? And it says it's not available, only available if I'm a logged in administrator, right? So let's take a look what actually happened here. So we send our post request, and you will see a session cookie is being set, right? And the session cookie is then being used subsequently on all the requests. This was my attempt to go to the admin panel, but it was denied, and I got a 401 unauthorized. So let's send this to repeater, and let's take a look at the session cookie in a bit more detail. So I will highlight this here, and then you can actually see that after URL encoding, so it's first of all URL encoded and then base64 encoded, you see serialization objects in there. Like you see O, so the O is basically, the object here is 4 digits long or 4 characters long, which is user. And then we basically have like a string with 8 characters, which is username, that's 8 characters. And then the actual username itself is another string value, S6, Wiener, and S5, admin. And then there's a B equals 0. So me as an attacker, I'm thinking, first of all, can I modify this? I surely can modify this, but if this is deserialized incorrectly on the receiving end, I may be able to get additional privileges. So how it reads for me, I mean, it's pretty straightforward. Like, okay, there's a username. The username is Wiener, we know that. But admin is set to false. Like, this is probably a Boolean value, right? Like B is 0 or 1. So what happens if I change this to 1? Basically. And this is a nice feature in Burp because in the inspector, you can do this on the fly, and then you simply hit apply changes. And once we have done this, our session cookie has changed, and then we send the request again, and all of a sudden we get a 200 because the application was successfully taking our modified object, and now we have admin privileges because we sent the whole thing to 1. So we changed the B value from 0 to 1. And in order to now exploit this, we have to delete the user Carlos. We will first of all look here for Carlos, and we will see that if I click that username, if I click the delete, basically what's going to happen is this is the path and the parameter to delete Carlos. So if I put this in here in my request, I will say get delete and then append the username Carlos. And then I hit send. And if all goes well, I get a 302 found, which is great. And if I go back here, I have solved my lab because I have successfully deleted the user Carlos. In order to verify this, I can delete, just browse quickly to the admin panel again. And now I only should see the user Wiener. Okay, so I hope this makes all sense, and I look forward to see you in one of my next videos. Hey guys, this is Martin, and we are in the information disclosure section. Today's lab is information disclosure in error messages. So it's a common problem sometimes for developers to avoid these verbose error messages, because verbose error messages basically reveal more than the ordinary user should be able to see. Like, for example, version numbers and things like that. And then based on that information, it can help an attacker to facilitate attacks against a specific version or look for vulnerable code and things like that, right? So what we're going to do today is I show you like a basic example in this lab around information disclosure and error messages. So if we go to our shopping application, we can browse the products, right? So I can click on the product, and what you immediately spot up here is there's a product ID field, right? And then I can change this to product ID number 2, and I get the next product and so forth. So this is not an IDOR because this is intended design, right? Like even though I can control the parameter, it's not an IDOR because this is public information and it's not like confidential information or any of that. So product ID 1, and then you get to see the product ID 1. Like I'm just showing you this. What I just shown you in the browser, this is the same like in Burp Repeater. But what happens if I put not a number in there, but for example, an X or a special character or something? Like how does the application react to this? And you see it is actually producing an internal server error. So it gives me a wealth of information here. For example, I now know that this is basically written in Java, because I see the keywords here, right? And then I get a lot of information, including down here, Apache struts and the version, the full version number of that specific web server, right? So I copied this out, and this is a leak. This is an information leak because this would aid an attacker now, like to go to Google and then start looking for exploits for that specific version, for example. So I submit this as the solution, and that effectively solves the lab. Okay, so this is a basic information disclosure vulnerability in error messages. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are in the information disclosure section. Today's lab is information disclosure on a debug page. So once again, there is an information disclosure. There's something revealed to the public which should not be revealed, sensitive information. And in order to solve the lab, we have to obtain something called a secret key environment variable. Okay, so let's get started here. So let's browse the site first and foremost, like let's load the site and let's basically, just check around like what's available, and it's just products. It's not much functionality. Um, I cannot log in or any of that, so I can just browse the products, right? So I can head over to Burp basically, and then go to the target tab. And in the target tab, I can basically, so it's the second one. This is our current target application. I can start browsing around, right? And I see like there's a resources folder with images and the lab header and some CSS for the styling. There's my product IDs in there, and there is like a product catalog, and yeah, nothing interesting, but there's a CGI bin, so that's like interesting to me. And there's a PHP info.php in there. So this is very interesting. So what I'm going to do is I send this file to Repeater, and then I will request that from Repeater, and then now I get actually the contents of that PHP info file. And if I like, this is fairly large, you can see this, right? Like there's a lot of information. So what you would typically do is you use the Burp search functionality in here, and then you can search for classical keywords like password or username, or like API or secret and stuff like that. So if I enter here secret, then I get 2 matches. And the first match is already the one I'm supposed to find. So there's a secret key defined over here. And here is the value of that specific secret key. So the secret key was available in publicly available source code. So this is the problem here with the information disclosure. I head over, submit this as a solution, and that should solve my lab exercise actually. Not sure why it's not. Maybe I had a blank in there. Okay, this sometimes happens with copy paste. And here we go, so it solves the lab. Okay, so this is an information disclosure on a debug page effectively. Okay, hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are in the information disclosure section. This lab here is source code disclosure via backup files. So the lab leaks the source code via backup files in a hidden directory. And to solve the lab, identify and submit the database password, okay? So, which is hard-coded in the leaked source code. So there's multiple issues here. Number one is hard-coded secrets should never be in the source code in the first place. But if then they are retained in a backup file, which is publicly available to the public, then that's even worse, right? So let's start checking around. And basically, you have multiple options for this. Like, for example, in Burp, you could start in the target tab, you could basically start the process of engagement tools and discover content. So it will spider this. But in the interest of time, we are not doing this. So there's some other ways where what you always can check is, for example, you can always check for robots.txt file. Robots.txt is simply for search engines in order to tell search engines what they shall index and what they shall not index. And typically, what is disallowed in there is of interest to a security researcher, right? Because they don't want this to be spidered by Google. So I take this /backup and put it in the browser. All right, and then I have actually 2 slashes in here, so just one. And then you can immediately see there is a product template.java.back. So that's a backup file. Interesting. So let's click on this, and then it reveals basically source code, right? Java source code. And if you start grabbing around there for certain passwords or for certain keywords like API, password, database, and things like that, you will eventually add up at something like this here. Okay, and this is basically credentials for the PostgreSQL database, and this to me looks like a password. It's a bit of a trial and error many times, but if you know Java, how it's written, this is basically the format. So you would copy this out, and we go head back to the main page, and we submit this as our solution, and that will solve the lab. Okay, so this was an example of the source code being available in backup files on the web server to the public, and then in addition to that, there was a password of a database available in that source code. I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin. We are in the information disclosure section, and today our lab is authentication bypass via information disclosure. So basically there's a lab administration interface, and in order to get to this lab administration interface, you either need to log in as an administrator, which I don't have the credentials for, and I might be able to brute force it, but that's not the purpose of this exercise. Or you can actually get to it via a local IP address, or which means basically the local host, and this is something which we're going to try to exploit. Okay, so let's get started. Let's head over to the website and browse to the admin. And then basically the error message we get is admin interface is only available to local users. So local users means like on that machine effectively. And that's interesting. That's an interesting error message. So let's head over to Burp and send this to repeater. So you will see, first and foremost, this was a GET request, right? Like this is a GET request, and again, unauthorized. So there's multiple verbs here I can test, like for example, option keyword, options, and I can try a post, and I can try a delete, and I can try, a trace, which is like a trace function. Oh, when I do a trace function, I get something called custom IP authorization. Interesting. So maybe, me as a security researcher, I'm thinking they're maybe looking at a header, which is not present at the moment, but the header is basically X custom IP authorization. So what if I actually take this header, right, and I go back to my GET request and I add this header, but instead of adding my real IP address, I will be adding 127.0.0.1, which is the local loopback interface, and hit send. And then all of a sudden, I get access to that specific admin portal. So what it was is the application is checking if a header is set, which is called X custom IP authorization. So it's doing purely authorization based on a header value, which is bad practice, right? Because as you can see, I can spoof that header. So I didn't come with my real IP address now, I came with that header value of local loopback. And now I have to delete the username Carlos. So I'm going to search for Carlos in here, and then I get the full path on how to delete that user Carlos. If I would click that link, I put this in here, I delete the user Carlos, I get a not found because I have 2 slashes in here. Okay, let's try this again. I get a 302 found, and to verify this, I just load the admin portal once more, and now I should only see the user Vina effectively because Carlos got deleted. Okay, so this is showing you authentication bypass via information disclosure. The disclosure was the header in the response, and then I was able to modify that header, and which eventually gave me access and allowed me to perform an action I was not supposed to do. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and today we are in the business logic / application logic vulnerability section, and our lab today is excessive trust in client-side controls. So business logic, application logic vulnerabilities are very often some of the most critical ones you can find, and they are pretty much impossible to find with automated scanning tools. So this is where real hands-on pen testing and hands-on research comes in, because a researcher needs to understand the application flow and what it's actually doing. And automated tooling has a lot of problems with that. They're pretty good on spotting technical flaws and things like that, but not when it comes to application logic and developing mistakes and things like that. So in our lab here, first and foremost, we have items to buy, right? So we have an account, it's like an Amazon or something, and basically the price of these jackets the jacket we are supposed to buy is too high. So let's head over. Let's log into our account first. And I log in with my credentials, Wiener and Peter. And you can see here, I have a store credit of $100. So if I want to buy this leather jacket and I add this to the cart, right? And then I go here to my checkout and I say like place order, it will say like not enough store credit for this purchase. Okay, so bad luck. I don't have enough money to buy this. So let me remove it. We have a blank card again. And let's head back to the leather jacket. So what I have enabled in Burp is, first of all, I'm highlighting and I'm showing the hidden fields. I show you this feature real quick. This is really useful for penetration testing. So if you head over to the proxy settings, basically you have the response modification rules, and there's these two options I always tick. It's unhide hidden form fields. So Burp makes it visible for me in the browser, and I also want the frame, the red frame around it. Okay, so this is just a side note. This is why you see this. But basically what I see is I can control hidden fields here. So what I'm interested in is this price. So this is $1,337. Those are the cents here, right? So this is too high for me. So how about I make this $1, right? And 0 cents, and then add it to cart. And then I head over to my shopping cart. And now I see that my total is just $1. I placed the order, and now I have bought a $1,400 jacket for just $1 because I was able to modify the price client side. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin again. We are in the application logic / business logic vulnerability section, and today we will look at the lab high-level logic vulnerability. So it is similar to the previous lab, but the developers have fixed certain things. So the previous attack, as you have seen it before, where I was able to control the actual price value, does no longer work. So let's head over. Let's log into our application with my credentials, and then let's go to the shopping cart, or let's go to the product first. So that's the leather jacket I want to buy. And as you can see, there is no more price for me to modify. So all I can do is modify the quantities, right? So I hit enter, I put it in my shopping basket. Right now I couldn't buy it because it's too expensive. But there's another vulnerability the developers haven't thought about. So for example, if you look at other products, for example, right? Like let's pick another product which looks nice, like this Burp protection. Yeah, that looks good, right? So let's put this into our cart. Now we have both products in our cart, right? And our total price is like $1,432 or something. And so we bought the Burp protection, or we have it in the shopping cart, and we have the leather jacket. But I don't really care about the Burp protection. I just want the leather jacket, but I only have $100, right? So let's head over and look at this request when we put the Burp protection into our shopping cart, which is this one. So I can replay this. And now effectively, if I go back to the shopping cart, I should have 2 of these Burp items in there, right? And let's just verify this quickly. And I do. It's actually 2. And the price has gone up even further, right? So that's what was expected. But the real issue now comes from the following. What happens if I introduce negative quantities? Like if the developers haven't sanitized that quantity input and they allow negative quantities. Like let's say I do -10. I buy -10 or -12 Burp protections. So I do this and it takes it. So let's verify what actually happened in the shopping cart. So if we go back to a shopping cart, we now see that we have a -10 value of $95, and our price has gone down to $381. So it's still too expensive. What I need to do is I need to send at least 3 more negative quantities of the Burp protection. And now I'm in the acceptable price range, right? Because now I'm at $94. I have 100 in store. My leather jacket is still in there. I hit place order, and that solves the lab. So basically now if you look at my total order, it was 1 leather jacket and minus 13 burp protections. And so this is an application business logic vulnerability that the developers allowed negative quantities to be introduced in the shopping cart, and it deduced the price basically, right? So this is a critical vulnerability because this could cost the company a lot of money, or could even lead to bankruptcy at the end of the day. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin again. We are in the application/business logic vulnerability section here, and today's lab is inconsistent security controls. So there is an administrative functionality that should only be available to company employees, right? And let's see if we can bypass this in one way or another. What I'm going to do is I'm launching the application. So to solve the lab, I need to access this admin panel and delete the user Carlos, right? So pretty straightforward, but we will see whether that works and how we can bypass this. So first of all, I don't have credentials. Credentials were not provided, so I register, right? Like I have to register first. So I have an email client, which is a simulated email, and I copy this email address out, which is my email address. So I call this Martin and my email address and the password Martin. And I simply register, and I should have received the registration link. Let's refresh this. And then yes, I did. So I clicked that registration link and the account registration is successful. Okay, perfect. So now I go to my account. So I just created myself an account as a regular user, Martin, and I log in. Perfect. So now I see that here is my email address, and that's the one I have chosen on sign up, right? So I shall get to something called admin, right? So let's go to admin, and the admin interface is only available if logged in as a don't wanna cry user. So that's a very interesting hint this error message is giving me here. If I now go back to my account and I'm thinking, hey, what if I change my email address? And if I say martin@don'twannacry.com or something, right? Like this, and I update my email, and you know what happened? I now have a don'twannacry.com email address. So the logic flaw here is that they are not verifying when I change the email address. When I first registered, I had to have access to that email account to get the registration link. But once I'm registered, they're not verifying anymore whether I actually own this email address, right? So now I use martin@don'twannacry.com, and in the minute I did this, the admin panel became visible because now the application thinks I'm a company employee because I have a don'twannacry.com email address. And now my job is to delete Carlos, which I'm doing, and that solves the lab. I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin, and we are in the business application logic vulnerability section. Today's lab is flawed enforcement of business rules. So basically there is another logical bug in the purchasing flow, and in order to solve it, we need to buy that leather jacket, even though we do not have that money in the account. Okay, so let's head over to the lab. As usual, we are logging in, but before we log in, we see something interesting here. There's like a voucher, right? So it says like use this on checkout. So new customer 5. Okay, yeah, interesting. What else is new? Oh, there's a newsletter sign up. Or yeah, let's sign up to the newsletter. Why not, right? Right, newsletters, maybe promotions. And we got another voucher. This time it's called sign up 30, right? Like let's use that as well. Like maybe we're getting, maybe this is 30%, right? Like 5%, 30%, something like this. So anyway, we will find out. So let's log in. We log in as Wiener and Peter with our credentials. And as usual, we want to buy our leather jacket. Here's our leather jacket. We put it into the cart. There's none of these other vulnerabilities from the previous labs apply here. But on the checkout, we have the option to apply the voucher code. So let's apply the voucher code. Let's start with the sign up, right? Like, because this probably gives us a higher discount. So let's scroll down. Oh yeah, this reducted the price by $401. $5. So let's try it again, So let's see, did it work? No, it did not. Coupon already applied. Interesting. Okay, so it's obviously checking this. So, but we have another voucher, right? So new customer 5. Let's see if that works. And let's scroll down. And yeah, it gave us $5. Not much, but it's still too expensive to buy. Now, what happens if I try to sign up 30 again? Because I used another voucher in the meanwhile, right? And there you go. See, like it deducted it down to almost 500 now. So now I'm fully aware of what the vulnerability is. It's basically you cannot use the voucher twice back to back, but if another voucher was used in between, it must be resetting some logic in the back end. And that's quite interesting. So now let's try to use the new customer 5 again to reset this. And it worked, right? And now let's apply the sign up 30 again and hit apply. And now the new Cust 5, which gives us another $5, and it's still too expensive, so we go for the sign up 30 once more. And now we're down to 0, even better. So we are completely down to 0 now. So we get the leather jacket gratis, completely free. We place the order and the lab is solved. So this was a classic example of like voucher vulnerabilities and, not using them back to back, but using another voucher in between and then reiterating between the two of them. And this effectively gives you a business logic flaw, which allows customer to purchase products for free, which is fantastic. Not so fantastic for the web application and for the business, but this is a vulnerability which is a classical application business logic vulnerability. Hope this makes sense and see you in the next video. Hey guys, this is Martin and we are in the HTTP host header attack section. Today's lab is basic password reset poisoning. So there is a vulnerability in the password reset process, which basically allows for password reset poisoning. And we have an account called Wiener Peter. And the goal is really like to basically reset the password of the account of Carlos, right? So let's run through the process with our own account first to see what's happening in the background. So I click forget password, I enter my username, which is Wiener, and now it's telling me, hey, please check the password reset link by email. So I access my email client and I can see here that I received this link. Okay, so let me just take this link and copy this into a text editor as well. And in addition to that, I will load this link. And then that allows me to change my password, right? So I'm going to do that. That basically finishes the password reset flow. But what you probably have noticed is that you don't have a controllable parameter here when you change the password. So I couldn't just say like end username equals Carlos, like in another lab we have done. That's not working, but the lab nonetheless is vulnerable. So let's take a step back. We have the post forget password. That's the one where we initiated it. And here is where we basically can control the username. And if we put in Carlos here and hit send, well, what's going to happen is Carlos gets an email with the password reset link, which is no good for me as a security researcher because I don't have access to Carlos's email account, right? So what else springs to mind? Well, host header attacks, right? So what if I change that host to a machine I control myself? So I have an exploit server here and I will simply copy that link, right? Like that URL effectively, and I will replace it. I will replace the host. Okay, and now if I hit send, I get a misdirect request. But let me tell you what that is. That's a flaw in the Portswigger Labs at the moment because they recently migrated everything to HTTP2, but it still has some flaws. So you need to revert this request to HTTP 1.1, and then you send it, and then you should get a 200 OK, which I do. And if I now go to my exploit server and if I check the access log, right, I see there has been a request down here. And the request came from the victim, and this is basically the token from Carlos. So I copy that Carlos token out. Even though I didn't have access to his email, it doesn't matter because the request ended up on my server. And so I'm now replacing that token I'm replacing my token with the token for the Carlos password reset. And then I simply load this whole string. And now I set the new password for Carlos to be Carlos as well. And I go over to my account, and now I try to log in as Carlos and see if that works. And it worked, and that solves the lab. So that's a basic HTTP host header password reset poisoning attack. I hope this makes sense, and see you in the next video. Hey guys, welcome to the HTTP host header attack section. Today's lab is a host header authentication bypass. So the flaw in the lab is basically that it assumes, or it takes the privilege level of the user based on the HTTP host header which has been set. So in order to solve the lab, we need to get to the admin panel and then delete the Carlos user account. Let's head over to the lab and see what's happening here. So let me try to basically access the admin panel, and it says like, well, the interface is only available to local users. So if I now take this request, send it over to Burp, and if I look at my host header, and well, at the moment the host header is going to that Web Security Academy domain. So what if I change this to localhost, right? And then simply hit send. And I don't get a response. And that may be the same problem as before, that I need to change to HTTP 1.1. And I render this, and there you go. So I have successfully accessed the admin panel because I have specified a host header of localhost. And now my job is to delete the user Carlos. So I'm simply searching here in the response for Carlos, which gives me the complete path to actually delete the username Carlos. So I copy that over. I append that to my initial request. I hit send, and I get a 302 found, which is great. Just to verify this, I will call the admin panel alone again and render it, and then it should be successfully deleted, and that has happened. The lab has been solved, and the confirmation can be seen here as well. I hope this makes sense, and I see you in another video. Hey guys, this is Martin. We are in the OAuth section here, and today's lab is authentication bypass via OAuth implicit flow. So first of all, if you are unfamiliar with OAuth, Portswigger has actually a really good theory section where you can read up on all the different kind of flows, like the implicit flow, the code flow, and so forth, to familiarize yourself with it. Just briefly, what is the implicit flow? The implicit flow is a very simplistic flow for the authentication portion. However, it's also very, very unsecure. Reason for that is because it's entirely happening in the browser channel with redirects and so forth. And there's no dedicated backend channel like an SSL backend channel where the more secure communication is taking place. So like in a code flow, for example. So the implicit flow is inherently insecure. And in this particular lab, we will have like a login capability via social media account. So this is quite common. You probably have seen this, like you go to an application and then it says like log in with Facebook or Apple or other service providers, right? And we will be taking a look at this today. So we have our own account to go through the flow. And then the goal is really like to take over the account of Carlos, and all we know so far from Carlos is his email address. Okay, so let's get started. Let's head over. If we click on my account, we basically are redirected to the social media login. You probably have seen this before. And typically this is like a Facebook or something where you then authenticate via a third party effectively, right? So let's do that. Let's go in, Wiener, Peter, sign in. And now we get the authorization request. So basically that target application would like us, or that our application where we are trying to sign into is now using a third party, and that third party requests certain information, like for example, profile and email, right? So we authorize this, and then we hit continue, and what should happen now is we should be logged in, right? And we are. Okay, so great. This is our account, and let's log out. Let's take a look at Burp, like what actually happened in the background here. So you will see, like when we first loaded like the My Account, we got the redirect, and we got to the social login, right? And then we went to the OAuth callback function. So nothing really special up until this point here, right? So we are posting an authenticate request, and then basically we receive our token back in form of a cookie, right? So if you go, for example, here to My Account later on, you will see that this session, this is basically, it starts with XH. So this is basically what was returned here, or what was set as a cookie. And so here's the problem with the implicit flow, right? Because what I can do now is I can send this on to repeater, and instead of using my own email address, I use Carlos's email address, right? Like, so I'm just sending this request over, and what should happen in theory is that I get a 302 redirect, and I get a session cookie, which is then the authorization token directly returned. So this is the problem also about implicit flow. There is, like in the code flow, you get a code returned first, and then you exchange this over a backend channel in a secure manner to get to your access token. Whereas here, it's basically all happening like in one request, more or less, right? So in order to check this, I can now say like show response in browser, basically, right? Like, so I'm replaying this request, but in the browser. And then what's going to happen is the lab is solved. And if I go to My Account, I'm now basically logged in as Carlos, right? So I have effectively hijacked Carlos's account. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are in the file upload vulnerability section. Today's lab, remote code execution, RCE via web shell upload. So basically what's happening in this specific lab is it has a file upload functionality where you're supposed to upload like a profile picture or an avatar or any of that. However, the system has a flaw as in it does not basically verify or validate the file type or the contents and things like that. So we know in this specific lab that it's based on PHP. This applies to all programming languages, not just PHP, but your exploit coding or your remote code has to match obviously the platform. And what's basically happening is if you upload, for example, a PHP file, and you then call that PHP file, so if it's successfully uploaded and the PHP code is executed, you have remote file execution. Remote code execution, basically, right? And this is dangerous because it's one of the most critical vulnerabilities, because it will give you full access over the target system. So let's take a look how this looks like. So to solve the lab, basically, we just need to read like a specific file, so which is home Carlos secret, right? So this is a file in the home directory / Carlos directory, and the file is called secret. In reality, you would put systems commands in there and stuff like that, but we can now go over to the lab and basically log in with our credentials. So I'm already logged in. That's fine. But basically, this is like a typical account functionality, and you will immediately see you can upload an avatar, right? So what happens, so normally, and I'm not demonstrating this, but normally you would take a JPEG picture, upload it, and then it shows there, right? So this is pretty straightforward. You have seen this before. But I prepared the PHP code, which is here, like this is the PHP code, simply to issue a PHP command and echo the file contents of this file. Okay, so it's a very simple function, and I have saved this file as something called upload.php. Okay, so this is the code. What I'm going to do is I'm going to, no, I'm not changing the email. I'm going to browse here and select my exploit.php file, right? I hit upload and I see that it was successfully uploaded. Okay, so let's take a look in Burp real quick, how this looks like. And then basically you see here's the post request, and this was the post to my account avatar. And then you see down here, so the content type is a multi-part form data, and effectively here, so content disposition is form data, the name is called avatar, the file name is exploit.php, and the content type is text PHP. So it doesn't do checks like normally it should do a multitude of checks. It should check for the file name or for the extension first of all. So if I only expect JPEG, it should only take JPEG or PNG or whatever. And then the content type should be like image JPEG and stuff like that, but it checks nothing basically. And here is basically the content of this file, right? This is the code I've shown you earlier, which is in this text file. And as you can see, the upload was successful. There was no filtering in place whatsoever. So if we now go here, we go back to our account, and then we will see like we have like a broken image, which is completely normal in this scenario because it's not a JPEG file, so it cannot be rendered as a JPEG or as a graphic file. But what I can do is I can right click this and open this image in a new tab, which I'm going to do. And then in there you have the solution. So this is basically, it has written that solution, or it's displaying the solution here when it's calling the exploit.php file. So it's executing the actual PHP code, right? And then it will display the result of this. So you don't get to see you don't get to see the PHP code itself, but the PHP code is server-side executed, and that's the solution basically to our lab. So let's go back here and submit this as a solution, and that should solve our lab, and it does. And that's the end of this video. Hope you enjoyed it, and see you in the next one. Hey guys, this is Martin again. We are in the file upload vulnerability section, and today's lab is web shell upload via content type restriction bypass. So if you remember from the previous lab, we were able to upload a plain PHP file which got executed on the server, so there were no restrictions, no checks, no sanitization, nothing in place. The developers this time around have put some defenses in place, but they are still bypassable. The objective remains the same. We are supposed to read a secret file from the file system on the target application, and for that purpose I'm using the same PHP code as in the previous lab, which is simply when executed, it's running this echo command, and then it retrieves the file content of this specific file, right? So pretty much the same as in the previous lab. Let's go to my account. You will see in my account you have this upload functionality once again with the avatar. Let's go there. Let's upload that exploit.php, and let's hit upload, and it says like, oops, sorry, the file type text PHP is not allowed. Only image JPEG or image PNG are allowed. Sorry, there was an error in uploading the file. So this was not successful this time around. Okay, so let's go over to Burp and look at our request. So basically send it to repeater so we can play with it. And what you see here, this is the same like in the first lab. And if I try this again, I will get this error message, right? Like, so sorry, file type text or PHP is not allowed. Okay, so it's obviously checking this. So it didn't complain about our actual file name, about the extension, about the .php, but it complains about this one here, the content type. So what happens if I just go in and play with the content type and say image.jpg, right? So I'm now trying to trick the server and say like, hey, this is actually, the content type is an image JPEG. And I hit send, and then it still complains, right? So I put image JPEG now, and it still complained here, but let's see what actually happened. So let's go back to my account and do this one more time. But this time we are going to intercept it in the Burp proxy. So we hit the intercept tab to on, and then we say upload. And what if we now change it to image JPEG? Okay, forward, 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 and check here. And now it says like, hey, the file avatars exploit PHP has been uploaded. So it was obviously working. Let's go back to my account, and we have this like not the full rendered picture because it's obviously not a picture. Let's open this in a new tab, and here you will have our solution once again. Okay, so what went wrong in my earlier request in Burp is it was actually checking, so it didn't like the image.jpg. It actually wanted to have something like this. Okay, so only this one is allowed. Okay, see that? So because JPEG basically can be in two forms, in JPG or JPEG, right? So it only allowed that one. This is why it went wrong earlier. So let's take this solution, submit it, and we have solved the lab. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the chart attacks section. Chart stands for JSON Web Token, and today's lab is chart authentication bypass via unverified signature. So the lab uses chart-based tokens for session handling. These are very, very popular in modern web applications and mobile applications. But the problem is that the server is not verifying the signature of any chart which it receives. So this is a problem because the chart is, I can modify the payload, and then if the signature is not verified, that the content hasn't been tampered with, this is a problem. And I'm going to show you now how to do this and what the problem is with that implementation. So let's head over and let's log in. And we are simply typing in Wiener Peter, and we are logged in, right? So let's go to Burp, and then you will see I'm making a post, and then in the response of the post, I get something called a JSON Web Token. You can spot this fairly easily because it has like 3 sections. It basically has the first section. Let me copy this out real quick. Let me go to my account here, and then let me copy this JSON Web Token out, and then you go to a website called chart.io. And this is basically where you can decode it. So the first section here shown in red is the header. So the header has like values, for example, which algorithm has been used for that JSON Web Token, kit values, and advanced things, which we will get back to later in more advanced sessions. And then it has the payload in magenta here, right? Like, so for example, it has the username embedded in the payload, right? Wiener, for example, in the expiration and things like that. And then the blue portion down here is the actual signature, right? So this is interesting. Also, what I highly recommend is you go over to Burp, you go to the BAP store extensions, and you install something called the chart editor, which is super useful when you deal with chart tokens. And I will show you why that is. So basically, when you now let's take this request and send it over to repeater. Okay, and then let's change the path to /admin first. And then we send it, and we get a 401 unauthorized, because right now I'm Wiener, I'm not admin, so I'm not supposed to actually get to the administrative interface, if that makes sense. So what I can do now is I have a new option is here when you have this BAP extension installed. It's called JSON Web Token. You can go over here, and then you pretty much see the same thing what we have seen earlier on chart.io. And the problem now is that if the signature is not verified, I can merely go in here, modify Wiener to administrator. Okay, and then basically my chart token has automatically been updated based on this, and I send it. And now I get a 200. So effectively now I see the admin panel because I have modified my JSON Web Token, and now I have administrative rights. Okay, and what I need to do is I need to delete the user Carlos. And if I look here, this is Wiener, this is Carlos. Here I get the full URL, like what I need to put in. in order to delete that user. So /admin/ and then delete username Carlos, like this. Looks like it worked, but let's verify this. Let's call the admin panel again and do a render. And now you see that the user Carlos is no longer there and it's just Vina. So this is the first lab, the basic lab, JSON web token manipulation when the signature is not verified at all. Hope that makes sense, and I'll see you in one of the next videos. Hey guys, this is Martin, and we are in the chart JSON Web Token Attack section. Today's lab is chart authentication bypass via flawed signature verification. So if you recall from the last lab basically we found out that the signature was not verified, and this time around it's different. So this time around there's another vulnerability whereby basically the signature, if I remove the signature altogether, then it passes through. So if I would now modify the request and leave the signature in, it actually tries to verify the signature and it verifies it. But if I leave the signature out completely, then it passes without any problem. So I'm going to show you this, how to exploit that. The goal once again is to get to the admin interface and then delete the user Carlos. Our own credentials are Vina and Peter, so let's head over to the application. We log in with our credentials and once again use that Burp extension I told you earlier, which is the chart editor. So once again, just for the sake of completion, our chart is set when we successfully log in. This is the chart, and then it's being passed on every request here as the session token effectively. Let's send this over to repeater. Let's try to get to the admin page first of all. So this is the chart token from Vina at this point, right? And it says unauthorized. So if you render this, it gives us the error message. It's only available if you're logged in as an admin. Okay, so heading over to JSON Web Tokens, you have a nice little attack functionality down here. You could do this manually as well, which is effectively, for example, using the non-signing algorithm. So this basically removes the signature altogether. So if you take a look here and I hit this, and you see it stops after the second dot. And so it basically removed the whole signature altogether. And now all I have to do is I have to go in here and change the username to administrator. And this is my new JSON Web Token. I hit send and I get a 200 OK. So I'm now successfully accessing the admin interface. And once again, the job is to basically delete the username Carlos. And I'm simply copying that command here, like what needs to be invoked in order to delete Carlos. And I append this to my URL. I hit send, I get a 302, that looks good. And let's just verify this once again by browsing to the admin interface one more time. And we see there is only Vina left because Carlos has been deleted. So this lab was simply removing the signature altogether and then bypassing any restrictions based on that fact. I hope this makes sense, and I see you in the next video.